Hello.
Hello, hello.
Welcome to Rust Week. Alex, would you please introduce yourself?
Hi, I'm Alex. It's great to be back. I can't believe it. What is this? The third time, fourth time?
This is the second Rust Week, but we've been doing Rust now before, of course.
Exactly. Yeah, I was referring to Rust now. It's like feels like I've been part of this community forever. Anyway, so I'm Alex. I work at the Nonviolent Labs. We do lots of awesome stuff in Rust for core internet infrastructure, and this is Tert, he's my colleague.
Hi, I'm his colleague. I also work for Nonviolent Labs, and I'm also one of the organizers of the conference. I would like to quickly go over some house rules and logistics and all that with you. So first of all, can please some volunteers raise their hands? There's some volunteers over there and over there. You can recognize them by their yellow shirts. So if you need anything, do you have anything? Just like you need some water, or you need to find the toilet, or whatever, find a volunteer and they'll help you.
Okay, so please remember there is a code of conduct for all of the events, for all of the dinners. Please respect each other, and please carefully read the code of conduct and take that into consideration.
Indeed, indeed. There's also a public live stream on YouTube for every one of the tracks. So, I don't know, if you're feeling like you need to just hang out somewhere and watch a talk remotely, that's fine. Also, hi to the people at home. And you can join our Discord. It's already super, super active. There's loads of social activities and just general chatter. People who are coordinating dinners together. It's really awesome to see. So that's a great place to hang out.
Yeah, so as for the logistics, all of the talks will be here upstairs in all of the different cinema rooms. Between each talk, you will have the opportunity to switch rooms. So all of the talks that you're really interested in and you want to switch between talks, that's perfectly fine. We'll accommodate the timing for that. All of the socializing, lunch, drinks, everything, that is happening downstairs. And if you have any allergies, then make sure to go to Hop. That is the bar on the left front of Spice. That's the other restaurant right there. So Hop, in case you have allergies.
Exactly. And then let's go through a schedule real quick for this day. So we have the main track here in Cinema 12. And then we have the compiler track, which is all sorts of compiler, but not necessarily the Rust compiler related things, in Cinema 7. And then there's the industry track in Cinema 8. The talks, most of the talks are open to everyone, but there's some special sessions that require an industry ticket. But you can definitely, if the schedule has like a little thing for each of the events there that shows you whether you can or cannot enter that if you don't have an industry ticket.
Okay, and there's Wi-Fi here, of course. So if you need access to the Wi-Fi, have a look at the back of your badge. There's going to be a QR code and all of the details will be there. So you want to talk to the audience a little bit more about what they're doing?
Let's do that a little bit. So first I want to know, we're with more than 800 people in this venue right now, which is amazing. But I'd like to know who was here last year. I'm going to step quickly out of the lights so that I can see.
Can we turn up the lights a little bit in the room?
That's too hard, but I can see loads of hands. Thank you all.
I'm asking hard questions. Let's not do that.
Thank you all for coming back. That's amazing. And maybe if you want to look around a little bit and see like who's in the same field as you are. So who's like doing back-end stuff maybe? Yeah, lots of back-end. Who's doing front-end? That would be awesome. Some WASM, some GUI stuff. Some hands for GUI, okay. Like maybe Internet of Things, embedded robots. Oh, that's also a lot of hands. Who's doing compilers and programming languages? Oh yeah, that's all the speakers in the front here. Who's doing internet protocols? Have I forgotten anything important? Shout out something. Sorry? Images. Game engines. Who's in game engines and games? Awesome. Nice. So I hope you've looked around, find each other in the hallway track, of course. And I think that means that we can go on to our first speaker.
Yeah, so the first speaker, I just talked to her. She just has the right amount of nerves to make it completely awesome. It's Taylor Kramer. She works on C++ and Rust interoperability at Google. And she's a former member of the Rust language design and compiler team. You're going to be great.
Hey all, thanks for the introduction, and thanks to everybody for being here today. My name is Taylor Kramer. You might also know me as Kramer TJ, or as the tech lead of Krubit, the C++ Rust interop effort at Google. Or potentially you know me as a former Rust language design and compiler team member, or maybe you know me as the woman who shows up at Rust conferences just to talk about C++ the whole time. Well, now you have another way to remember me. I'm also the woman who shows up at Rust conferences and cat ears to talk about empathy. So let's talk about how I found Rust. So late one night in January 2016, I was an exhausted college student working off 4 hours of sleep, a bottomless supply of Diet Coke, and the completely unfounded belief that I just needed to fix this one last seg fault in order to get my gene pairing algorithm working. Throughout this experience, I found myself thinking, there has to be a better way. I knew many great developers built amazingly fast, complex systems in C and C++. However, I'd also developed a fondness for languages like SML, Haskell, and Scala, whose designs allowed me to write APIs that prevented whole classes of bugs from ever being expressible. Then I heard about Rust, and how it combines the efficiency of C++ with the correctness properties of functional programming. No more memory unsafety and data races? Sign me up. Elm-style guided error messages and a lightweight package ecosystem like Ruby and JavaScript. Wow, systems programmers can have nice things. For me, the greatest successes of Rust come from its embrace of positive sum design. Rather than zero-sum style decision-making, in which the needs of front-end developers are viewed as counter to the needs of embedded developers, Rust encourages building tools and systems that learn from the best of both worlds. By understanding and empathizing with the feelings, needs, and design trade-offs made by other language communities, Rust is able to deliver far more than if it had evolved out of one particular development style. As Aaron Turin put it in his Listening and Trust series, Rust seeks to simultaneously appeal to die-hard C++ programmers and to empower dyed-in-the-wool JS devs, and to reach several other varied audiences. That's uncomfortable. These audiences are very different. Building shared understanding requires patience, a sense of community, and boatloads of empathy. The work of connecting and understanding one another becomes harder as more people enter the conversation. This work, though, is both possible and necessary. Delivering on Rust's core mission to empower everyone to build reliable and efficient software will require active and intentional empathy. Throughout the rest of my talk, I'll explain what I mean by empathy and why we need it, why it's getting harder as our community grows and expands. I'll convince you that empathy can be learned and provide you with some tools for empathic listening and expression. Finally, we'll talk about how to productively discuss trade-offs. In order to have a more productive conversation, I should first tell you what empathy means to me. I see empathy as a group of 3 related concepts, 2 feelings and 1 action. The first, empathic distress, is an internal feeling of pain caused by observing the suffering of others. For example, the sense of dread that you feel when seeing another user post some auto-trait HRTB async error on Reddit or Zulip is empathic distress. This mirroring of emotions can be helpful for understanding the experience of others, but frequently results in avoidance or burnout. Frequently taking on and feeling the pain of others commonly motivates people to withdraw from the source of stress or repeated pain. Rather than step in and help others, people experiencing large amounts of empathic distress will withdraw and find themselves avoiding interacting with other people who are suffering. A more helpful feeling is empathic concern. Unlike empathic distress, empathic concern allows for emotionally connecting with and caring for others without taking on their pain. For example, when we see someone else's overwhelming template expansion error, rather than sharing in their shock and horror and logging off chat, we can provide care and resources for debugging the issue. Finally, we have the last form of empathy, expressed empathy. This action form of empathy is the one I'll discuss the most today. I like how Nico Matsakis explains this last form of empathy in his blog post called Empathy in Open Source, Be Gentle with Each Other. Nico says that empathy is not about being nice or making the other person feel good or even better. Being empathetic means understanding what the other person feels and showing them that you understand. Acting with empathy should be a genuine exercise in opening ourselves up to another person's perspective, helping them process their emotions, and improving our own understanding. Okay, but really, why is this important? I've quoted Nico once already, so how about another one from his recent blog post on Ubuntu adopting Rust? What Rust needs most is empathy. Okay, well, appeals to authority alone work great with this crowd, right? I don't know, I can stop. No, all right, more seriously, let's talk about 4 avenues through which empathy is critical to the experience of using Rust. The most obvious example of a group which requires empathy is new Rust users. Though many of us have now learned our way around the language, it remains incredibly valuable to consider the experience of newcomers and how we can make it easier for them to learn and connect with the language and community. Many users who have been using Rust for a long time operate with dramatically different workflows. While the upstream open source community largely relies on cargo, many working in large companies, embedded, or security critical environments use other systems. While some of us spend our days thinking about the ins and outs of pointer provenance, others are squeaking the last little bit of performance out of a GPU, throwing together a quick CLI tool, or hustling to deploy the latest Rust-powered Python package. It's one of Rust's great strengths that we have the opportunity to learn from all these different perspectives. When designing changes to the Rust language itself, empathy allows us to focus on building a shared understanding of the views and experiences of these different groups, and work together to build consensus solutions, though not necessarily unanimity. Aaron's Listening and Trust series describes the positive sum process as starting by seeing different perspectives and priorities as legitimate and worthwhile, with the faith that we can find strictly better solutions than had we optimized solely for one perspective. I promise to give you a break from Aaron quotes soon, but this one from his 2017 post on the ergonomics initiative was too good not to include as well. Transformative insights can be fragile. They start out embedded in ideas that have lots of problems. If we're too quick to shut down a line of thought based on those problems, we risk foreclosing on avenues to something better. We've got to have patience to sit with the ideas that are foreign and uncomfortable and gain some new perspective from them. We've got to trust that we all want to make Rust better and that good faith deliberation is the way. I believe that the commitment to including diverse perspectives in our design process is a huge part of Rust's success. By including perspectives from various specialties, we not only make Rust usable in more spaces, we allow all users of Rust to benefit from the institutional knowledge those specialists bring to the table. The final reason I think empathy is critical shouldn't come as much of a surprise to any of you. When people feel unheard, scared, or mistreated, they feel bad, become unproductive, and may even disengage from the community entirely. I work at Google, and we've published quite a few results of our internal studies on what makes teams effective. The greatest single factor is psychological safety. As our blog post on the topic states, those on teams with strong cultures feel safe taking risks in the face of being seen as ignorant, incompetent, negative, or disruptive. In a team with high psychological safety, teammates feel safe to take risks around their team members. They feel confident that no one on the team will embarrass or punish anyone else for admitting a mistake, asking a question, or offering a new idea. I want to live in a world where writing Rust code, opening an issue, contributing to open source Rust tools, or showing up at a conference feels welcoming, productive, and safe. I wouldn't be here if that weren't the case, and I imagine the same is true of many of you. So let's make our best effort to understand the perspective of others and make sure that they're heard and included. Let's act with empathy. The bad news, empathy is more challenging than ever. Human instincts for empathy evolved in a world where most communities were relatively small and tight-knit. As described in the book, The War for Kindness, participating in these communities gave us countless chances to learn about the character of our neighbors and to hold each other accountable. We had a future together, meaning that kindness and cruelty could be repaid. Actions taken to protect or harm those around us had direct consequences. But we're no longer operating in small bands of neighbors. In Peter Singer's 1981 book, The Expanding Circle, he explains that though we once cared for a narrow group of people, our kin, perhaps a few friends over time, the diameter of our concern has expanded beyond tribe and town. Now it encompasses the nation. These days, it encompasses the world. Empathizing with large, often anonymous groups is really challenging. In laboratory studies, people actually express more empathy for one victim of a tragedy than they do for 8, 10, or even hundreds. As the Rust community grows, conversations will include more people who aren't yet familiar with one another, haven't built a shared sense of trust and community, and don't necessarily have a baseline level of context or respect for one another. This is a situation I've seen occur many times to friends, coworkers, or other folks new to an open source ecosystem. When showing up for the first time on GitHub, Zulip, or Discourse, newcomers may be disregarded because they're missing context for a complex, years-long discussion. This can result in valuable insights and potential new contributors being lost. This experience is made worse when, as Nico describes it, newcomers mistake the impassioned comments from a random contributor or perhaps just a troll for the official word from project leadership. It only takes one rude response to turn somebody away. Often, disagreements arise from a mismatch of assumptions and axioms or shared context. As Manish Goragaonkar says in his article on Rust governance, Scaling Empathy, these mismatches are easy to identify in one-on-one discussions. End-to-end discussions, however, make it harder to converge on shared vocabulary. Aaron also describes this issue. If our community grows more quickly than we can establish shared values or norms or culture, we could easily descend into acrimony and tribalism. This is especially challenging right now, as tons of developers are flocking to Rust in order to fix AI-discovered vulnerabilities in their C++ code. Many of these engineers are unfamiliar with the Rust language or community. Now is the moment for Rust safety and reliability guarantees to shine. But if we can't find a way to connect and build mutual understanding with this new generation of Rust users, we'll wind up in a fractured and burnt out community. So enough of the doom and gloom. As I said at the start of the talk, I'm here because I believe that these are problems that we can address and improve upon. If we accept that empathy is a requirement for our mission, we have to treat it like any other technical skill. It isn't a personality trait. It's an actual protocol we can optimize. Acting with empathy is a skill. Unlike early researchers who once believed it was an innate trait and couldn't be learned, we now know that it's possible to make both short and long-term improvements to our ability to empathize. In fact, even simply knowing that empathy is a learnable skill can result in improved empathy and interpersonal relationships. In 2008, Dr. Erica Wise ran a study in which Stanford freshmen were asked to write a letter to a younger pen pal, explaining that empathy could be trained. Months later, the students who wrote that empathy was trainable continued to believe it. Remarkably, their empathy had also outpaced that of the control group. Students who wrote about empathy as a skill reported having more close friends than their peers. Empathy is learnable even in extreme cases. By default, when exposed to videos of others in distress, the brains of psychopaths didn't display the same mirroring responses as neurotypical brains. However, when asked to imagine the pain of others, psychopaths did display a mirroring response. These results suggest that psychopathy is not an inability to empathize, but rather a reduction in spontaneous empathy. Perhaps more relevant to members of this audience, it's extremely common for neurodivergence to be accompanied by additional challenges due to either alexithymia, which makes it difficult to process emotions, and rejection-sensitive dysphoria, in which perceived failure or rejection results in severe emotional distress. I won't get into details right here about how to work with these conditions specifically, but if you suspect you might experience one or both of these, consider reaching out to a professional, as both of these have been shown to be responsive to therapy, and rejection-sensitive disorder is actually also responsive to a number of medications. So Stanford students can improve their empathy by writing about how empathy can be improved. Psychopaths can be prompted to choose empathy, and common emotional processing conditions can be treated. But what specific actions can we take to communicate more empathetically? In this next section, I'll describe some tools I've personally found helpful and explain how to try them out. I'm not a trained psychologist or anything, so please judge for yourself, but hopefully there are ideas in here you can try for yourself and find useful. So to start, let's talk about a couple things to avoid. Moralizing judgments are statements that imply wrongness or badness on the part of other people who act in ways that don't align with our own values. Personal criticisms and attacks will always be difficult to hear, but inserting judgment rather than more objective statements will easily trigger defensiveness and disagreement. Examples include blaming, insults, labels, or put-downs. As a general rule, anything of the form like person is negative adjective will create disconnection. The second category to avoid is denial of responsibility. Try to avoid deflecting to some immutable higher power with language like had to or policy or, it's the law. Instead, replace language that implies a lack of choice with language that acknowledges choice. We're dangerous when we're not conscious of how we're responsible for how we behave, think, and feel. Similarly, demands often taking the form, you must, will often be understood to mean that you're not interested in learning or being empathetic, but instead are going to insist on a particular outcome without being willing to have a conversation. Finally, when attempting to connect with someone, try to avoid escalating the tone of the conversation. We've all seen examples like the comment above where someone suggests that will ruin the language if a certain choice is made. Escalation encourages a zero-sum environment, an us versus them battle, completely at odds with the positive sum thinking that has led to Rust's best innovations. If everyone's yelling, truly listening becomes very painful, and you grow a thicker skin, in part by learning not to take other people's feelings so seriously, which then means they need to yell louder. This is again from Aaron's Listening and Trust series. Now that we've discussed some things to avoid alienating, what can we do instead? One technique I personally like to employ is nonviolent communication, first described by psychologist and international peacemaker Marshall Rosenberg. Nonviolent communication encourages making conscious statements about what we're observing, feeling, needing, and requesting. From now on, I'll refer to this strategy as OFNR, or OFNR, rather than nonviolent communication, both because it's silly, helps me remember the steps, and because I don't like naming things after what they're not. By understanding and processing each other's observations, feelings, needs, and requests, we allow people to feel heard while also ensuring that their use cases are appropriately considered. Here's the process in detail. Let's start with observation. Observations are concrete facts that we observe that affect our well-being. When making an observation, try your best to stick to objective realities. For example, an evaluation statement like Saturday has a macro called deserialize that automated our JSON parsing and allowed us to delete thousands of lines of code is an example of an observation. But a judgment statement like, Saturday is the best thing since sliced bites is not. Separating these types of statements makes it easier for others to read observations without being alienated by a subjective judgment they may disagree with. All right, feelings, that's the F. Feelings are how we feel in relation to what we observe. Feelings often start with I feel and may include things like, I felt so relieved we wouldn't have to maintain our brittle JSON parsing logic anymore. The next thing to focus on is needs. The needs, values, and desires that create our feelings. These needs don't necessarily need to be absolute things like food, fire, or water, but could be things you value, such as, I want my JSON objects to be easy to update and maintain. Finally, requests, the concrete actions we request in order to enrich our lives. Avoid vague and abstract language, which often contributes to internal confusion. Be as specific as possible. It can be difficult to be specific about requests, but think about how difficult it will be for others to respond to our request if we're not even clear what it is. Requests are especially important when talking to a group, as is often the case when working in open source. Be really clear about what action you want to see in response to your comment. When we're not clear about the response that we'd like, we may initiate unproductive conversations that end up satisfying no one's needs. I'm sure you've all had the experience of sitting in meetings where people chat about a topic but don't develop any concrete plans or follow-up. Explicit requests help avoid this problem. Putting our feelings, needs, and requests together, our example might look like Saturday has a macro called deserialize that automated our JSON parsing and allowed us to delete thousands of lines of code. I felt so relieved that we wouldn't have to maintain our brittle parsing logic anymore. I want my JSON objects to still be easy to update and maintain. Can you help me ensure that Saturday works with our new build system? This is a rather mundane example, but I think using the structure helps people understand and connect with my perspective on things. Now that we know the basic format of Offner, observations, feelings, needs, and requests, we can use this framework to express ourselves. But we can also use it to listen empathetically. When listening to others, pay attention to what they're observing, feeling, needing, and requesting. Try using reflective listening techniques, either through direct reflection or paraphrasing. Nonviolent communication suggests reflecting back the speaker's thoughts by asking questions which demonstrate understanding and elicit clarifications. For example, I'm against this RFC. I don't want to get rid of mod statements. I think they're very important. I understand that you value Rust's existing mod statements and don't want them to be removed. Can you say more about what role they play for you? They make it easy to temporarily remove modules while refactoring. Okay, so you have as a design constraint that we need to continue supporting workflows for temporarily excluding code from the build while refactoring? Yes. Okay, notice how each question here reflects back information from the speaker's comment, allowing the listener to demonstrate that they've understood and dig deeper for more information. As a result, the listener now has valuable information to consider about Rust's module system. Notice the difference from questions that don't reflect, such as, what did I do that you're referring to? How are you feeling? Why are you feeling that way? What do you want me to do about it? This set of questions asks for information without first responding to the speaker's reality. Make sure to listen for long enough. Allow others the opportunity to fully express themselves before turning your attention to solutions or requests for relief. When we proceed too quickly to what people might be requesting, we may not convey our genuine interest in their feelings and needs. Instead, they may get the impression we're in a hurry to either be free of them or fix their problem. If this process of paraphrasing to demonstrate others seems tedious, note that it's actually been shown to improve the speed of communication. Studies in labor management relations demonstrate that the time required to reach conflict resolution is cut in half when each negotiator agrees before responding to accurately repeat what the previous speaker said. Paraphrasing of emotionally charged messaging, though, often creates challenges. For example, if a speaker says, "I feel disgusted by the perpetuation of AI and I refuse to use it," and the listener paraphrases this as, "It sounds like you just prefer AI tools," it makes sense why the original speaker would feel unheard. The listener may have been attempting to carefully de-escalate, but they failed to demonstrate that they understand the emotions at play. Rather than paraphrasing, try to more directly reflect and match the intensity of emotionally charged content, such as, "I get that the perpetuation of AI feels visceral and disgusting to you. Can you say more about what causes you to feel so strongly?" Obviously, there are exceptions to this. Don't engage with or reflect code of conduct violating speech. Just report that to the moderation team. In summary, Offner teaches us to communicate without alienating by focusing on our own observations, feelings, needs, and requests, and how to receive other people's communication by paraphrasing or reflecting via questions in order to demonstrate understanding. Okay, before we move on, I want to clarify that it is absolutely possible to have a productive communication without using any of these specific strategies. A particularly poor failure mode of these tools is when folks within a community start mandating the use of particular communication tools, causing others who are new or unfamiliar with the format to feel unwelcome. Please don't do this. Instead, use Often and other tools as resources to consider when you're looking for other ways to provide increased empathy in your own interactions. Now, Offner helps us to collect information, but how do we process that information and work together to make decisions? That's when we need to discuss trade-offs. This next section of advice is heavily influenced by a talk given by one of my coworkers, Nina Chen, called Expose Your Trade-offs. The core insight is that conflict between engineers is often the result of mismatched or misunderstood trade-offs. As Titus Winner says in the Software Engineering Handbook, making good engineering decisions is all about weighing all the available inputs and making informed decisions about the trade-offs. It should be intuitive then that conflict is caused by misunderstanding or differently evaluating different trade-offs. So how can we help reduce the resulting conflicts? Here are a few suggestions. Number one, figure out your own trade-offs. Understand the factors that influence your decision-making, how they weigh against each other, and what judgment calls you're making in service of different costs and benefits. Number two, try to understand other people's trade-offs. Take the time to really understand the factors that led to other people's decision or preference. Be open to having your mind changed. Often, we're first exposed to the end results of other people's decision-making process, and the outcome can look weird and yucky until we understand the larger context in which the decision was made. Write it down. Nearly every interesting decision will be questioned. Documenting the factors that led to a decision being made helps share context with other developers. Additionally, having a written source of documentation for a decision makes it easy to reference when onboarding new users. These decision docs can also serve as a basis for updating and reevaluating decisions. Let's dive into each of these a little bit more deeply. When identifying your own trade-offs, try to figure out not just your goals, but why they're your goals. Consider whether it's possible to reframe in terms of more fundamental goals to avoid a classic XY problem. Henry Ford is often claimed to have said, if you asked people what they wanted, they would have said a faster horse. Instead of asking for a faster horse, try asking for speed. Maybe someone will invent a car. Drilling down to more fundamental goals helps make implicit requirements explicit, which may open up the solution space or may help others understand your reasoning. Be clear about choices that impact multiple goals. For example, you might have to choose whether to deliver short-term features as soon as possible or whether to guard your codebase against tech debt that will make it difficult to change in the future. Avoid zoning in on a single goal, as this might cause you to over-optimize at the cost of other important factors. Aside from the immediate problems caused by negative externalities, failing to consider multiple goals can cause you to thrash back and forth. For example, if your goal starts out as making good search results, you have a whoopsie and you have bad latency. And so you go into an emergency mode where you have to fix it. Oh, we fixed latency. Oh, but now the search results are bad. So you have another emergency. And you wind up bouncing back and forth between different kinds of brokenness. This is a real example. It's actually happened. Instead, what you can do is intentionally weigh trade-offs. Consider whether multiple goals can be met with Rust's best trick, positive sum solutions. Finally, do your best to clearly separate subjective goals like code health from objective goals. Subjective goals are just as real as ones that can be measured objectively, but reasonable people often disagree about them. This is especially common when discussing design patterns or programming language design. Some people think shorter variable names make code clearer. Others think longer variable names make code clearer. The Haskell community refers to this pattern as Wadler's law. The simpler and more subjective the feature, the more room for argument there is, and the easier it is for hundreds of people to storm in and add their own take. When making decisions based on subjective goals, elaborate on the reasoning to believe that a particular change accomplishes the goal. If it's a personal preference, clarify that and leave room for others to disagree while still finding consensus. It's fine and expected to see some instances of, I don't agree with your metrics or valuation, but I can see how you come to that conclusion. Remember that trade-off evaluation is subjective. It depends upon context. It may change over time with new information. It includes many dimensions people may not initially have considered. And finally, it's subjective. Seriously, though not all decisions are equally correct, there are frequently multiple similarly valid solutions to a problem. Really try to understand other people's perspectives and be open to having your mind changed. We talked earlier about how expressing empathy can help others to process their emotions, but expressing empathy is also critical for growing your own understanding. A classic example of why it's critical to consider other people's perspectives is Chesterton's fence. A person walks up to a fence, says, "I don't know why there's a fence here, let's take it away." Another person counters by saying, "If you don't know why the fence is there, I certainly won't let you remove it. Come back when you know why the fence is there, and then we can talk about taking it down." When you hear someone make an argument that doesn't make any sense, do you think, well, that was a bunch of nonsense? Or do you think, what factors are they considering differently from me? Are there things I'm not considering? Nina's advice here is to genuinely try to understand their perspective and restate your understanding of it. Allow them to confirm whether you interpreted it correctly. This process allows you to frame potential solutions in terms of how they address not just your needs, but the needs of others. This is very similar to the nonviolent communication model we discussed before. Whether it's in a design doc, an RFC, or a company-wide best practices site, explain your trade-offs, constraints, goals, and what alternatives you considered. Consider starting the doc by explaining constraints rather than starting with a solution, as this can leave more space open for other ideas. If that doesn't work, write a pro-con list for one option, then consider other options which may address those pros and cons differently. In summary, figure out your trade-offs, try to understand other people's trade-offs, be open to having your mind changed, and write the result down. Human empathy is critical to Rust's success, but we can't rely on the borrow checker to catch our errors here. We've spent years perfecting zero-cost abstractions so that we can trust our code, but the real scaling bottleneck for our community is our ability to understand one another across increasingly diverse backgrounds. When we treat empathy as a vague soft skill, or not as a vague soft skill, but as a technical protocol, we can ensure that Rust remains an inclusive community where positive sum solutions are the norm. As you head into the rest of Rust Week, I hope you find these tools helpful. Be as patient with your peers as you are with a particularly stubborn lifetime error. And remember to extend that same empathy to yourself when you inevitably screw up. If we can scale our compassion as effectively as we've scaled our ecosystem, there's no limit to what we can build. Let's make Rust not just the most reliable language to code in, but the most empathetic community to grow in. Thank y'all.
All right. Thank you, Taylor. That was awesome. We have some time for questions if you want.
Yeah, sure. If people have questions.
There's a catch box, which is a microphone that we can throw to you. Jonathan has it over there. Does anybody have a question? I can't see anything, so...
Yeah,
somewhere over there, I think.
Okay? Here, okay. Ibe Kingma, that's my name. The list you showed a few slides ago looks a lot like a PEP, Python Enhancement Proposal. So you may want to take a look.
This
or
one?
Do you know them? Would you comment on them?
This list here? I don't know about the Python announcement protocol, sorry. So this isn't directly inspired by that, but it might be transitively inspired by that.
All right, more questions? Mic is on its way.
Are there any things you can suggest for third parties if we're reading, say, a long GitHub with an issue with a lot of people arguing back and forth? Is there any role that third parties who are not involved in the discussion directly can play to kind of help, say, bring down the temperature a little bit in a discussion?
That's an interesting question. So you're talking about third parties who aren't currently participating in the discussion and aren't necessarily like people who would otherwise have engaged in that conversation? Yeah,
it doesn't have to be on GitHub, but sometimes in a work thread, I'll see people
Yeah.
getting really heated back and forth. And in work, I kind of have the personal context to be able to say,
Yeah.
hey, can we, to restate what I think I see going on. But you could definitely be doing the same thing in a broader community, like a GitHub discussion.
Yeah, that makes sense to me. I think in my personal experience, the most valuable thing people can do when they show up on like GitHub threads specifically is try and write a comment that correctly summarizes and like displays kind of a reflective understanding of what people in the thread are saying, so that people feel like their perspective has been heard and noted. We do have things already in like the RFC process for listing concerns more officially, so that they can go through the process and make sure that folks on whatever particular team have a chance to review them. But yeah, and anytime people go in and they can like accurately summarize the various issues and concerns that people are listing in a thread, that's always really helpful. But yeah.
Thank you.
Awesome. All right, I think then we're wrapping up.
Cool.
Give it up for Taylor. Now, you all have the opportunity to switch tracks. We have the opportunity to fix the flicker on the screen. And we'll get our next speaker set up, which is Waffle. See you soon. 25 yet.
With seconds to spare.
Wait 1 second, there's still a lot of late, so there's still a lot of people coming in.
I'm waiting. You're gonna do great. Do you want me to say anything fun? Ricochet robots?
Sure. Say, competitive pathfinding game.
Ja? Als jij het licht uit doet, ga ik beginnen. Hello, welcome back, welcome back. Hiya. Our next speaker is Waffle, and it's working on the compiler team, working on explicit tail calls, the never type, and so much more. It's also now employed to work on Rust by the RustNL maintainer team, which is absolutely fantastic. You get to work full-time on Rust now. Waffle is also one of the co-creators of what is called the Gay Rust Quiz. You can. I've tried it. It's ridiculously hard, but you should definitely try it. The URL for it, and it's making me say this. It's this.quiz.is.fckn.gay. That's the URL, and it's a great quiz. And finally, it's very good at a competitive pathfinding board game called Ricochet Robots. If you want to, be competitive with Waffle, that's what you should do. And I can tell you're going to lose. That being said, please give it up for Waffle.
So I'm sure you all have a lot of questions about the never type, this talk, etc. You came here after all. Fortunately, I have lots of answers to you. Unfortunately, those answers are to questions that you probably did not want to ask. But first, before we go to the main question of when is never, let's all came to the same kind of starting point, and let's get to know what is never. It's the never type crash course. So the never type is a built-in, uninhibited type. Built-in here means that there is no definition of the never type in the standard library. It is part of the language. And you can kind of name it with an exclamation point. Exclamation point is the never type. That's the syntax for it. Then uninhibited means that it doesn't have any values. You cannot create it. But that also means that if you have a value of it in a function or anywhere else, it means that the code is unreachable because there is no values of the never type. And the never type is the type of so-called divergent expressions, such as the return, loop, or panic, expressions which never actually terminate, which somehow affect the control flow in such ways. The fact that it can only exist in an unreachable code also allows us to have a so-called never to any coercion. We allow coercioning or assigning the never type to any other type, to a variable of the type. And That in turn allows us to write code like if A, then some expression else return, and the type of the return is never type, and then it is coerced to the type of the then branch, of the block in this case, which is very useful. I'm sure many of you have used this. And then type means that it's a type. And what? And it is also equivalent to an enum with no variance. Because an enum with no variance has no constructors, it means that you cannot construct it, so it's also uninhabited. So it is kind of equivalent to the never type, except that we don't have recursions for user-defined type like this. And then you can convert an empty enum to the never type using an empty match, because you basically match on all the variants of the enum which are none. So this just kind of works. So when is never? Actually, why are we asking this? So a long time ago, when I just started learning Rust, there was a meme. I couldn't find it, so this is my artist rendition of it. The never type is named after its stabilization date. There's also this one, which I did find. 3 things you can watch forever: flowing water, burning fire, Rust core team trying to stabilize never type. And if you look at the tracking issue for the never type, you can notice it was open since 2016. That's 10 years ago, by the way. Hope you don't feel old yet. So when is never? Story time. Back in 2024, I had the brilliant idea of, wait, I'm a Rust contributor. The never type is not stable. Surely I can just stabilize the never type. OK, so the first step, figure out the status quo. What is the current status? Why is the never type not stable yet? You look at the tracking issue for the never type. Here it is again. It's OK, give it some time. Oh. Spoilers, I accidentally skipped a few slides. Wait. This is working so far already. OK, so good. And you see that there are 415 hidden comments on that issue. And by now there are 517, or maybe by this day it's even more than the couple days ago that I made this screenshot. So the comments look like this. OK, let me just... Oh, it's so blurry, you can see it. There is so much comments there. And hidden in those comments are 5 previous attempts to stabilize the never type. But of course, surely I can do this. Surely I'm the one to do this. OK, well, that's unfortunate. That's a lot of things to think about. So next, step 2, think about them. Think about them really hard, about all the comments and all the other issues which are linked from that tracking issue, and all the comments on those, and PRs, and things which are poorly documented, and Step 3, document all the things that you thought about. Document the status quo, the previous attempts to stabilize it, why they failed. Document the goals, what do we want to achieve with this stabilization, what we're trying to do. Document the trade-offs, why it's hard, what can we choose differently, how this affects our goals. Document proposed solutions, what do you think is the way to go, and so on and so forth. And also discuss it. This is the document that I wrote in 2024 for the language team to try to move forward with the never type. Finally, 4th step, do the work. Make a few PRs, do some changes, make more of them. So this was year 2024. This is 2025. And like, to be clear, all those pairs are not trivial necessarily. On some of them, there are hundreds of comments. There's so much discussion, so much experiments. And this is this year. It just keeps going and keeps going. Okay. So you do work until it's done. It's how it works. What? I thought that stabilization is just you make the thing not unstable, you make it stable. Surely, right? Where does all this work come from? What happened? Well, I think it's time to consult the stability syslog. To stabilize a feature is to provide a guarantee that its uses will not break in the future. As such, stabilization is necessarily a high bar to clear, as we need to convince ourselves that we can provide such a guarantee. Clearing that bar requires a deep understanding of the feature, to know what we're guaranteeing, and making sure that the feature works in all edge cases, to make sure we won't need to change it in the future. This often calls for a long tail of, usually, small issues. Sometimes making a feature work 90% of the time is trivial, and the last 10% are impossibly hard. Stabilizing a feature also often requires introducing breaking changes, as new features can conflict, usually in obscure ways, with existing code. This is the case with the never type, where the never type fallback trademark causes awkward interactions between things. Everyone say thank you, Stability syslog. Okay, so let's talk about breakage briefly. What did Stability syslog mean when it said that the never type requires some breaking changes? So we want to make infallible the send library type, which is stable right now and is an empty enum. We want to make it an alias for the never type. However, actually doing this breaks a bunch of existing code. Why? What? So bear with me. Consider an example. You have a function which returns a result where the error is infallible. It can only ever return OK of unit here. And then you have a function which can print an error if it happens, right? So it takes any value which implements the std error trait. And then you call do something, and in the error case, you print the error. Of course, it can never happen. The print error code is unreachable. But maybe this comes from a macro. Maybe this was the easiest way to handle it. There are many cases. And this code works. It compiles. Everything is good. However, if you change the error type to be never, this stops compiling. And the error says the trait bound unit std error is not satisfied, which is weird because we didn't do anything about units. We only changed the error from infallible to never, and as I told before, they're equivalent. They're both uninhabited types with no values. So what's going on here? Well, the compiler actually sees the code more like this. There is a never to any recursion converting the E expression here of the never type to an arbitrary type. It can be anything. We could kind of emulate this in surface Rust as like doing a cast to an underscore as the type of the cast. To let the compiler choose the type for underscore here for the cast. But the problem here is that there is nothing to tell the compiler what type to choose for the underscore here. It could be any type implementing error trait, but there are so many of those types. So if you would literally write this, the error would be the underscore doesn't come, can be inferred, right? The compiler can't choose a type for the underscore. And because this is not very good, we have a default, specifically in cases where the never type is cursed to anything. The compiler kind of inserts information to say, hey, if you don't know the type of underscore, insert the default instead. And for historical reasons, the default is unit. So this is what the code looks to the compiler now. And now it's clear where the unit comes from and where the error happens, the compilation error, because the unit indeed does not implement the error trait, even though both infallible and never do. So that's unfortunate. Again, that's probably a bad idea to use unit as a default. We didn't know back 10 years ago. It's fine, whatever. So make infallible be equal to the never type while leaving never type fallback to unit breaks code. Solution? It's easy. Change fallback to never type. Then in the previous example, the never type would be kept as the never type, which implements the error trait. Everything would work fine. That breaks different code. Okay, this breaks code that looks like this. So you have a function. You're welcome, you're welcome. And it returns any type which implements the default trait. It doesn't matter how it's implemented. Meow. Then in an if, you call that function. And then in the else branch, you do return. This example might look silly. You cannot imagine how common this type of code is actually. But that doesn't matter. So what happens here is that the type of the meow call here is kind of an arbitrary type, t. And then in the else branch, you have an never to any recursion, which can incur fallback. And because there is nothing else constraining neither of the types, and because they must be equal to be returned from the if, the type of t here depends entirely on the never type fallback. And so this compiles just fine if the never type fallback is unit, because unit does implement default. But this will break if the fallback is to the never type, because never type doesn't implement default. You cannot create any values of the never type, so there is nothing to return from the default function. That's unfortunate. So fallback to unit breaks code. Fallback to never breaks code. What do we do? OK, so I have a solution. And the solution is to do a staged rollout, kind of. Which is to say, we introduce a lint which detects code that will be broken. Specifically, the code from the last example with the meow function in return, code like this. And because in the compiler, we can kind of check if that would happen, if a similar error would happen, we can emit a warning for this. Then step 2, change fallback in an addition to make sure that the code that is newly written for the new edition will not need to incur any breaking changes, that it will use the new semantics that we wanted to use. And unfortunately, this also requires a step 3. We need to change the fallback everywhere, on all editions. And this does break old code, unfortunately. And the reason for this is additions are useful for syntactic changes, right? We introduced the async keyword in an addition. But they're not as useful for semantic changes. Here, to make sure that everything works correctly, we need fallback to be to never on all additions. And so we also need to break all the additions, sadly. But to kind of help with this, we have the lints, which tell people that their code will be broken in future Rust versions. Profit. This is the solution that we're currently still implementing. We're implementing most of it, except the first step of changing it everywhere, because it still breaks stuff. And this is just one example of the problem, of the kind of problems that you have with the never type. There are many more, but I will not bore you with details for them. So when is never? Maybe that's the wrong question. Let's ask, how is never? Have you ever considered that? So the current status is as follows. We have a good idea of the kind of breaking changes that we need to introduce, both on the previous slide and some other things. And we acquired that knowledge through making numerous creator runs, where creator is a tool which compiles all publicly available Rust code with the old compiler and the new compiler and compares the results so that we know what kind of code breaks by our changes. I have a good idea of what we still need to do, although it's only my idea. I haven't fully communicated with all people involved in the decision process. And most of the work is actually done, right? The lint that I mentioned was implemented 2 years ago. It has been made deny by default and be reported in depth so that if you depend on the create, which emits this lint, you will also get this lint, right? About a year ago. And so there's like just minor cleanup. There's also a PR to stabilize the never type, although don't celebrate yet. Please, please, don't. No, it's not done yet. Don't. There's still work to be done. As I said, there is a long tail of things that you still need to do at the end. And even though it might be small things, it's still a lot of work. I'm convinced that we can do it. Actually, drink water first. Stay hydrated, everyone. Okay. So I'm convinced we can do it. Because, one, it seems like we have finally explored all the problem space. We know all the problems. We know possible solutions to them. The end is near, hopefully, probably, maybe, I hope. At least most of them, right? You never know if it's all of them until you actually do it. Number two, I'm stubborn, and I'm committed to doing this. I am. And number three, I'm working full-time on Rust. So I actually have the time to do the work and communicate with all the people involved and everything. Speaking of, that's a lot of work. That's a lot of PRs, a lot of discussions. It's work for contributors. It's work for reviewers. It's work for people discussing the design. And the thing is, not everyone is as lucky as I am. In a recent survey for the people working in the project, only 35.7% are funded at all. And out of them, a lot of funded only part-time to work on Rust. And this doesn't even include people who contribute without being part of any of the Rust teams. So when is never? When is it? Soon, probably. Trademark, hopefully. This year, maybe, would be cool. But the question that you're probably actually thinking is, why are my favorite features not getting stabilized? Pleading ice emoji. And there are lots of things here. It's just hard, as I hopefully made clear by explaining all the things that have to be, that have been done for the never type. It requires time and thus money for the people spending their time. And we just don't have enough of either in the Rust project. And there are attempts to improve this. There is the Rust maintainers team, which employs me. There is the Rust Foundation Maintainers Fund. There's also the funding page, which has links to personal people sponsoring pages. But at the end of the day, if you know a Rust developer, hug them. They're not okay. Thank you.
All right, it's time for questions. Who has any questions for Waffle? Now I need to walk forward a little bit and make sure that I'm not completely blinded. There's a little bit more light.
Yeah.
There's a raised hand over here. Ah, there we go.
Is that me? Okay. But then, if I understand correctly, when the never is stabilized, it will break things that are not fixed. What is the plan for these crates that are long forgotten and unmaintained, and nobody has access to that? What do we plan to do?
Okay, thank you. This is a great question, actually. So I made a recent crate run to check what things are still broken. And what we found out is that there are only, 10 or 20 roots of causes, roots of issues, right? So there are only about 20 crates which are broken themselves, but there are a lot of crates which depend on those crates. And so what we did is we reached out to the maintainers of those crates and told them, hey, there are a lot of people depending on your old versions which haven't fixed the warning yet. Can we help you release patch versions so that for affected people, fixing this problem is as easy as running cargo update? And we did this for a bunch of crates. A lot of the maintainers just fixed the warnings and released patch versions themselves. Some we helped, some I helped. And so hopefully we can minimize the impact as much as possible. But at the end of the day, you will not be able to compile all old Rust code, and there is just kind of no way around it, sadly.
Okay. Next question over here.
So first, let me say thank you for this great talk. Although I would have liked to have more cat pictures, but yeah, it's great. And perhaps one very stupid question: would it have been possible to coerce to unit if the expression in question is a semicolon expression? So it's yeah, basically coerced to unit anyway.
No?
It seems a lot of the complexity is coming not from wanting to stabilize the never type, but change the definition of infallible. Was a approach of stabilizing never, but keeping infallible as its own distinct type considered? And if so, why was that rejected?
It was considered. Of course, that would avoid all the breakage, so it's kind of desirable. However, it makes us very sad that infallible and never are now not equal, and a lot of the code still needs to use infallible because we can't change it either. But then never is kind of the type that you want to use, but everything uses infallible still. So it was considered, and I've talked at length with the library team and the language team. But eventually we decided that we still want to proceed with making infallible never, because it will, at the very least in the future, lead to a better language.
Okay, we have 5 minutes for questions, so don't worry, you can both.
No,
you go first.
I asked if I could first because I kind of have a refined version of their question. Namely, one of the breakage that you showed was because we changed the definition of the infallible type and it no longer implements a trait. Would it be able to reduce the amount of breakage by still implementing those missing traits that are currently implemented for infallible for the never type?
No. So the problem here is that those traits cannot be implemented for infallible or for the never type in a meaningful way. So for example, default would have to either loop forever or panic, which even though it prevents the compilation issue, it will just convert it to a runtime issue, which is even worse.
Well, it won't be a runtime issue because it doesn't exist, right?
No, so it won't be a runtime issue because the problem in the example there is that you have 2 branches. In one of the branches, you have kind of real code, a call to a function. And then in the other one, you have return. And so the type of the return affects the type that the function returns, but the function itself is always reachable. You can call it. And so it would cause runtime issues.
Right, it would need to return unit like it does today with the default example. Okay, thank you.
Thank you very much for the talk. I had a question. I don't know the Rust internals at all, so this may not be possible in the slightest. But it seems to me that if you have the never type, you know statically that this branch will never, or this block will never be run, would not be much simpler to just simply not analyze the block because you know it will never run?
So we actually partially do this. If my memory serves me correctly, we don't do borrow checking in unreachable code. Kind of as a side effect of borrow checking being run on a CFG, which means that unreachable code just does not exist in the representation that we run borrow check on. But it would probably be bad to not do type check in unreachable code because often people depend on the result of type check kind of to make sure that some property holds. And it's nice to use unreachable code for making sure the property holds because you know that it will not infer any cost at runtime.
Okay, then we have a question all the way in the back there.
Hi, so without reading the million of comments already posted about this, I'm guessing it's been actually answered already. Was it considered, or rather, why wasn't it solved with some kind of like 2-stage inference thing where you can, like presumably you could replace those inference variables with ones that can only be a unit or never, and the trace system would, in the case where you only implement default for unit or only implement error for never, you could like disambiguate that and then only do the fallback to a specific one for those where the trace system doesn't disambiguate. Like I'm guessing the reasons why it doesn't work. Maybe like, I don't know, like multiple inference variables in the same bound or something, but...
I get your idea. So this has been considered and tried, but what we ended up is a system which is both complex, both in the implementation and kind of in the language semantics, while not actually being able to fix all instances of breakage. So maybe if it was a perfect solution, we could consider it, But as it was adding significant complexity to the compiler without actually fixing the problem fully.
Okay, the last. I'm going to close the queue. There's one more question behind you.
Sorry.
You've had your hand up for such a long time. You deserve. You deserve to have the last question.
Thank you. I have no questions for implementation because there is no power in the universe more powerful than an autistic deep dive. Could we improve the addition system to fix the last problem?
No. Thank you so much for your question.
Ah, super nice. And now it's time for a break. Thank you so much, Waffle. All right, listen up. So all of the catering is downstairs. There will be various glitter tattoos available again. So I will be getting one to match my pineapple. There's a 40-minute break. We're going to be back here at 11:40.
Hi. Hello. Welcome back. Before we continue, I'd like to quickly mention a few sponsors. So we have Amazon Web Services who are sponsoring us at a diamond level, which is fantastic. But maybe more importantly for all of you here right now, our coffee is sponsored by Comper. I've definitely enjoyed that coffee. I hope you have too. Now, I will introduce our next speaker to you. This is Stefan Baumgartner. He is a moderator at Eurorust. He's also in the past organized some Rust Linz meetups. So he's very involved in the community. He's also an MC here tomorrow.
Yes.
Which is awesome. Thank you so much. And you wrote a couple of books on programming, but mostly TypeScript, right?
Yeah.
So if you're interested in TypeScript, then you should pick those up.
I have a Rust book on the shelf that I want to finish at one point in time. I just don't know when. So but it's a passion project, so I will finish it one time in the future.
Maybe ask him for the manuscript as a PDF or something. Slip him some banknotes under the table. With all that, please give it up for Stefan.
Thank you very much. Good morning, everyone. Welcome to my talk. I was supposed to say that I'm the last speaker between you and your lunch, but then I found out that there's some other speaker coming right after. So I think I had some sort of race condition in my schedule. But let me ask you, what are you all doing here? I mean, really, why not at my talk, at the programming conference? I mean, some guy said that, give me a second, coding is largely solved. We can all go home now. Let us collectively fast forward to our midlife crisis and start the sourdough phase of our lives. The loaf of the left was pulled out 5 minutes before I went to the airport to go to this conference. I'm very proud of it. So, thank you very much. And with that, thank you and goodbye. So this is my talk, and I guess, give me a second, this slide came way too early. Another race condition, I'm very sorry about that. Good morning and welcome to my talk. I was supposed to say that I'm the last speaker between you and your lunch, and then I found out that there's another speaker coming right after me. So I had some sort of race condition in my schedule. But let's start again on the whole AI thing. Sorry, this bothers me. I think it's not our collective experience with generative AI and LLMs. This, for example, is Dave. I used to work with Dave at Dynatrace when he was the VP of marketing, and he left the company. Ever since he started to dig deep into LLMs, like everybody on LinkedIn does for some reason. But at times he struggles. Look at that. He said that in the past hours, ChatGPT has continually lost its mind in conversation with me. Is anyone else experiencing it? I'm on a pro account. To which I replied, I think you're onto something, Dave. I also continually lost my mind in conversations with you. Dave is a fun guy. I'm sure he appreciates a little joke. He didn't like it, though, so who knows? But I think that even without LLMs, creating code, creating conversations can be frustrating at times. Like this person on Reddit who had a problem with writing async Rust code using Tokyo that just didn't feel right. It was not clean, which is a term that I heavily dislike for many, many reasons. We can happily talk about that afterwards or in the Q&A. What I wanted to say that it was not efficient, it was not maintainable, and it had some severe problems. This was the text from this Reddit post. I want multiple processes to be launched and monitored asynchronously. That I have got arc mutex all over the place, and I sometimes run into deadlocks. There might be a connection between those two things. Also, there's a ton of nesting of if and match going on, and I can hardly keep track of all the mutexes. And they're right. So we are going to see some code, and a disclaimer up front, we're going to see some code where not all of it is ideal, far from it. But we are not here to shame that code. We are not here to shame the coder, not at all. The coder reached out for help, and we are here to help. This is code that any one of us could have written in our career, and we improve it by unearthing idioms, aligning it with good everyday patterns that you can use in your Rust programs, and architecture that is good for async programming. Some of that code that you see, you might think, okay, this is something that you wouldn't have done that way, and I'm pretty sure you wouldn't. But in the end, we're getting out some phrase, some sentence, some rule to live by that makes all future code that we write better. Just remind yourself of what Taylor said this morning. That we need to be nice people, need to be a nice community, even for people who produce code that we at times don't understand. All right, let's read it. So this is the code. Everything clear. It's so amazing. So usually this is one of the best jokes where you have a small screen and you show lots of code nobody can decipher. But actually on this screen, you really might to figure out what's going on. That's pretty incredible. One thing that you see here, or not, depending on how sharp your eyes are, is that what the author gave us was just a method in a struct, nothing else. So we had a lot of things missing. It's a method inside a struct. What's the rest of the struct? What are the surroundings? How is this method being called? The surroundings matter as much as the code inside the function, especially if you have so many arg mutexes running around in your program. I actually used an LLM to help me with that. So there will be some generative AI in there. I'm very happy to discuss in the Q&A or afterwards what our collective consciousness on generative AI is, because it's a hard topic. I don't have any opinions. I'm just confused like everybody else is. But what I did, I asked some LLM to say, this method is part of a struct. What could the rest of the struct look like? Also, can you create the main function that calls the method? And this was really, really helpful. So all the missing pieces, it was trying to figure it out from what it got in the code, how the return values were, because they didn't have any type annotations to work with. So it worked as long as it could compile it and run it to get the result, which was, funnily enough, a deadlock, but at least we could reproduce the problem. And I also asked, what is this code supposed to do? I can figure that out on my own, but this was a fast forward to see what's actually going on. So what is it supposed to do? It spawns, you know what? Let's not go through that list. Let's look at it piece by piece. This is the start. First, we spawn a child process of some task with piped standard out, standard error. You can already see some struggles in the function signature. It's a method that returns self. When we don't know if this is a creation process of that struct or not. We don't know what the fields of that struct are. But this is a pattern that is usually really hard to unlearn if you did 30 plus years of Java. So this is something that you might connect the dots on. Also what you see is a lot of clones here. So we get some process description. We also don't know what the process description looks like. This is also a struct that we had to recreate. Also a really good use of LLMs in that case. And if we get the process description as a calling argument and have lots of clones inside, this usually indicates a bigger ownership problem that we have inside our function. And most likely also from the calling side. Next, the code creates some logging directories. Twice, once per stream, for the standard out stream and for the standard error stream. Again, there's a ref in there, and I don't know if this is necessary. I didn't get any compiler input or output or whatever. But to me, this also looks like some ownership problems happening that manifest again because we're accessing the same struct again, try to access different fields, need it in some other way. This might also indicate some ownership problems. And this is beautiful. This is just an error that is being matched, but nothing done with it. So I think the only thing that this does is to satisfy Clippy, because there's some rule where you say you need to do something with the return value. And I guess I'm not that far from it. Next up, and this is cool. So if something goes wrong, if the spawning of the child process failed, it returns a fake error process. And from this return value, so it returns a self, from this return value, you can figure out a lot. First of all, you have lots of mutexes everywhere. So what you return is just data that you fill at one point in time, hopefully, and the process description that we got as a calling argument. And this is where the ownership problems come in. You put it in as an owned value, you return it again. This is why you need to clone all the values, because at one point in time, you're moving out the whole struct again, so the caller can work with it. Also, it has a process status error, whatever the process status is. We couldn't figure it out. We created some fake struct for that, some fake enum, some error logline in the vector. But you know what? This is not an error state. Not far from it. So we have ways to define errors in Rust. We are doing that later on. But this is not an error state. It's being treated as such, but it isn't. Next step, it spawns 3 background tasks for standard out logging, for standard error logging, and for something else. We are going to get to that in a second. This is the preamble before spawning those tasks, and pew, 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 pew. Look at that. That is the typical problem that you get in Rust code, where you need to have the value, but you need to unwrap it. You don't have proper error handling in place. That's why you call unwrap. And if you have that before maybe locking a mutex, then your process breaks, then you have a deadlock problem or a poisoning problem. Also a good indicator that something is not right. And again, some clones on the same data that we already had. The one thing that actually works is the vector where the author wants to store all those log lines. It's an arc mutex, so an atomic reference counter, over a mutex mutually exclusive access of a vector. We need that arc to be for that mutex to be passed around in different tasks or threads. So a typical pattern that we see in lots of concurrent async in parallel Rust code. Then we spawn the tasks. So I don't know why it's being block scoped. Maybe some problems with accessing the same names or whatever. But here we clone the mutex. We do some other things, opening the file, making sure that we can append to it, and then finally, as long as we get lines from standard out, we are pushing them into the locked mutex that we locked just the line before. Also very interesting is what comes afterwards. We also want to write it to the file, but if writing to the file doesn't work, then we log another error in the vector. All right. We're not only spawning standard out and standard error loggers, we also spawn a polling waiter. And this is a very interesting task. There's so much going on. I didn't figure out what exactly, so I just dropped it in the end and nothing has changed. But we are getting there. First of all, the comment says it polls the child without holding the mutex, except it holds a couple of mutexes here and there. Different mutexes, but still. And also what's very interesting, once we have some exit code from the child, we wait for it to finish. We either get some exit code, then we return some exit code, or we get no exit code, then we return none. Or if you have an error, then we have something, but it is none. Whatever that means. Again, this is something that we can get rid of. And last but not least, and this is the biggest tell that something is going wrong, is the last line. We sleep for 100 milliseconds and try the whole thing again. If you do asynchronous programming, waiting for something intentionally, not by event, is hugely a really huge red flag. So this is a big tell that something is wrong in your code. So let's emphasize that. Huge red flag. All right, and this is the meat of the program. In the end, it returns immediately with all 3 tasks that run in the background. And again, this is the struct that we return. We return a child arc that needs to be inspected. It maybe has a status code that needs to be inspected. It has the log lines that maybe are being added to, and the process description that we add again. So lots of stuff going on, not the most ideal function signature. There are a couple of tells. So first of all, what we see is very clear. We have unclear ownership. Stuff that we pass as arguments, stuff that is happening inside our function needs to be owned by many things at the same time. And this is what's really, really hard in Rust. This is why we have Rust to be honest, to make those things hard. And this is why you have many, many workarounds. Lots of clones, lots of arc mutexes, lots of stuff that needs to access the same thing at the same time. We also don't have clear states. We don't know if something is considered successful or considered an error, because we have the struct that gets updates randomly with states that might indicate an error or not. We don't have clear errors. And in the end, it's designed async, but it's not really async. We have some complex orchestration inside the function, but also presumably outside, because if you spawn all those tasks, you get the data back, but not the tasks, and wait for data to happen. Then you have some orchestration problems on the outside. You have something that needs to peek into those tasks and can't. And there's one reason for all of that we are going to unwind and try to make better. And the reason is that the author wanted concurrency, but they reached for shared state. And this is not always, not in the slightest, the right thing to do. All right, but before we start with that, let's do some hygiene. So let's make a couple of things that are good practice, that make your code much, much nicer to read, much, much clearer, much, much more intentional, without getting to the actual problem of the async structure. 2 quick hygiene fixes. First of all, error handling. I'm doing refactoring talks for 6 years now, and it's always error handling. It's this is the biggest impact. This makes your code so much nicer to read if you just know that if you have an error, throw it up and let somebody else take care of that. So this function should not just return self, maybe it shouldn't return it anyway, but also an error if something goes wrong. So we introduce a process spawning error struct. It implements error, it implements display, it implements debug, then it's an error. And we also create some conversion implementations. So if you have an I/O error, which happens a lot in file access, standard out reading, and async, we can bubble it up into our own error. So we return a result here. This result now represents a state. It represents the fact that something can go wrong and we can act on it, instead of having, some status that might say something went wrong. We implement a conversion from a standard I/O error to our error if something happens. And suddenly what we can do is, instead of checking if the child was able to be spawned, we just return an error. And we also can say, if we can't access standard out or standard error for whatever reason, we can say OK or else, which means that this is an option. And we actually want to only work with it if we have a value. We don't want to work with it if we don't have one. So we can convert it from an option to an error, bubble it up again. Here again, if spawning didn't work, bubble it up again, and everything becomes much nicer and much easier to read. I particularly love OK or else. So this makes so many things so much nicer. If I would establish a guideline, I would say error handling is not an option. Yeah, this is a joke that you just can bring at Trust conferences. I know. In introducing custom errors helps to define boundaries, introduces state, and sets clear expectations. So this is the meat. And we can now design driven by the failed state of an operation. There's so much potential for failure inside our code, and we now have a vehicle to react on that. Again, some prompts that help me there. I always ask questions. Is there a custom error that can unify all potential failed operations? Then it scans through the function and creates this error. And how would the function interface look like if it would return a result instead of the struct itself? Next, custom types for better abstractions. What we see in this code, we access log files everywhere. So either by creating them or by writing to them. And this code is scattered throughout the entire function. For example, here, where we actually open the file after creating it much, much deeper down in our function and write to it in the spawn task. So we also mix creation and writing with reading in an async task. So there's lots of potential of not knowing where stuff is supposed to be. And this calls for a unit, a representation that encapsulates operations and the creation and can be used wherever we like, but encapsulated. So we create a log file struct. Don't worry about its contents. The implementation is actually the stuff that's more important here. It holds ownership over a file handle. That's all it needs. And here we have the write line function. There's also some error handling checking involved, some nesting involved. We can abstract it away by just calling write line, and it returns a result if it didn't happen. What's also interesting is that the original author intended that if you don't pass a directory, the code still works. You just can't log it anywhere, but why bother? So that's a possibility. It's just empty calls then to writing it. It still logs into the vector. But I wonder if this is just an artifact of struggling with error handling and struggling with options, or if this was intentional. So there are a couple of unintentional features in that code, which I assume are unintentional features. First of all, is it okay to not write into a log file when this is basically what you should do? And also in the OG code, if writing to a file didn't work, the code logged an error message in that vector. I don't think this is necessary in the new setup, but only with the stuff that's coming in later. And this is also so beautifully meta for this talk that I take one problem, but it leads to many, many other problems that are happening somewhere else in that code. So lots of race conditions expressed through code lines. That's beautiful. But yeah, so those are questions that we can ask ourselves. If this is still necessary, if the new design might ask for something different. Couple of guidelines that I would say you can follow if you want to create custom types. First of all, they create necessary abstractions and should encapsulate the data they hold and what operations they should allow. This is basic object-oriented programming in a programming language that doesn't support object-oriented programming, but this is good. Follow that. Also, everything that I said last week, type trait still works well. If I have some prompts for that, I would say which operations are tied to log files. Can we combine them into a single struct? And how does the control flow change if you have a struct representing log files? All right, let's get to the meat, spawning tasks. And now we need to zoom out a little bit and look about what's actually happening here. So all code aside, this is what's going on. We have 3 data structures, a vector with collecting log files in a mutex, the child process that's being inspected if it still runs, and the process status, which says, okay, this is executed successfully or erroneous or whatever. And we have lots of different tasks accessing that content. If it's the readers that push lines to the vector, or if it's the main function that reads it, or if it's the waiter that needs to check if the child process still works or not. So lots of stuff accessing the same data through an atomic reference counter, through a mutex. And those are some big async tails. So first of all, we have too many reads and writes on shared data. And the tasks are not designed independently when they should be. So since everything needs to know the same, connects to the same, even things that don't seem connected are connected. And the orchestration happens outside by trying to look inside, which is also a big async tail that this might not work out in the end. And the solution to that is to turn everything upside down. Good morning and welcome to my lunch. I was supposed to say that I'm the last schedule between you and your speaker, and then I found out there's another race condition coming after me. Again, this is all jumbled. I'm sorry, but establish some good async guidelines, and we go into that in detail. I think, and this might be controversial, I think async is not about making something concurrent or parallel or whatever. It's about making pauses count. There are some tasks happening in your code that wait on I/O, that wait on network data or on some event happening in the operating system, and you wait until this happens. And during that wait time, you can do something else with the valuable compute time that you have at your hand. And this is what async is mostly about. That it runs in parallel, that you can do many things fanned out, is nice, but it's an extension on a concept that builds on interleaving tasks. Also, I think if you design tasks, you need to design them so they are able to stop. They can end on their own. They know everything that they need. They don't need to know anything left or right. So tasks should not know about each other, but they should be able to communicate with each other. If we look at some of those guidelines in detail, this is basically making pauses count. This is taken from the book Programming Rust, published by O'Reilly. It's excellent. I highly recommend this book. It cleared async for me. And all those pink bars are basically when there's a pause if you write standard synchronous code. And in this pause, you can do something. And the other one I want to emphasize by using a quote from Rob Pike, who created Go, is one of the creators of Go. You can say about Go what you will, but some of the principles are really, really good and are actually much, much better implemented in Rust than in any other language. And one principle, one Go principle from Rob Pike is don't communicate by sharing data, share data by communicating. And if we take this principle at hand, so this is most likely the most important thing that you should take away from today, then we take something like that and focus more on what are the tasks supposed to do and what data do they need to do that. And if we do it like that, we see that we can spread out the reader and the readers for those two streams. They get info from standard error and standard out. They wrap it in a log message, and then they should send the log message to a collector which puts everything into that vector. So this is a typical fan-in pattern. Instead of having multiple writers fighting over one mutex, you have one task that owns the vector, no mutex, no arc necessary, and gets data from the other tasks to write them in. And the great thing about this is if we transform it into something like that, then we can define how the boundary should look like. It can be either at the collector, and the caller is the main function, or it's at the sender where we send the message and the collector lives outside, maybe inside the main function, or we can make spawn even smaller that we can have multiple of them that point to the same collector. So we have building blocks now that we can rearrange, and the only thing that needs to be done is that we want to send a message from the spawned task to some task that collects it. And to do that, we use channels. Really quick on what channels do. So there are many, many channels in the standard library, in Tokyo, in other async libraries. One that is the most prominent one, I guess, is multi-producer, single consumer. You can create multiple transmitters, and if you call send on them, one single receiver gets the message, and the receiver lives as long as there are senders still in scope, so they keep count of how many senders there are. To implement that, we create a log message struct that makes a distinction between is it a standard out message or is it a standard error message, so we can have some representation if we call to string or if we display it. Then we create some multi-producer single consumer channel, and we spawn multiple reader tasks where we either clone the transmitter, this is by design, which creates another transmitter pointing to the same receiver, or not. Looking at the spawn stream reader real quick, so ignore all the trade bonds for now. They have been created by refactoring through Rust Analyzer, which is awesome, love it. But I want to focus more on, and we also mix some log file creation and task spawning, which is something that we maybe should split at some point in the future. But that's an artifact of a longer ongoing process. But this here is the meat. So we spawn the task, and instead of putting everything into the vector that we need to access, we take the transmitter and send a message out and wait for it to be received. On the other hand, which is a while loop, we have the receiver here. We receive messages as long as transmitters exist. If transmitters don't exist anymore, this returns none, and the while loop drops. And here in this while loop, we can push it to log lines, which we own, or we can write it out to the log files, which we own, so we don't have any ownership problems anymore, not at all, no arc, no mutex, no shared access. And now we can decide. So everything that's left is waiting for the child process to end and returning an exit code. This is all it needs to do that. I decided for it to be the last thing that happens when I spawn a task, but I can also decide to spawn that and maybe send that exit code as well to some orchestrator, to some collector. And this is the most important thing. We now have flexibility to design the software as we want it to be, because we don't have this shared data in the middle. We rather have messages that we want to receive and that we want to send. So yeah, and with that, I basically removed everything that needs to be shared. You return the log lines, you return the status code, and that's it. We also got rid of all the ownership problems with that. So you don't need to have any clone anymore, because when we create the log file, everything that needs to be there is there. If the process description is necessary to be looked at from the outside, I would say let the called function decide if it needs ownership, and then it has ownership. It doesn't need to clone anything. But let the caller decide on the clone. So if the caller needs process description as well, clone it at the function caller. All right. I have 3 more minutes. If I want to have one hot take in this talk, then it's that I think arc mutex is a code smell, or a code tell, however you want to call it. This is, of course, not entirely true, but there are situations where it's totally fine, but it usually shows that the way you design your application focuses more on the data that every task needs to access rather than the purpose of a task. What is the task supposed to do? And think of a different interface on how to create input and output. And in Rust, complex things are possible and fine, but Rust does not allow you to cut any corners, and this is great. If something is complex, it's visible, and therefore also findable, discoverable, and sharing data is not an easy thing. It needs attention, and all arc mutexes show that it needs attention. To close it, it's not perfect, but we can still do a lot of things. I don't want to go over that. But once we remove shared state, every task has a defined scope of execution, can end on its own. The collector is independent from the number of tasks and just cares about receiving messages. It can be moved anywhere. You can redesign your application to your needs, which is great. And we have no deadlocks, no shared data, no concurrent reads, and each part of the program has clear ownership. All right, good morning and welcome to my talk. I was supposed to say that I'm the last person between you and Rose Peck, which is coming after. She's awesome. Please go and check out the talk. I think there's still a lot to do in the other code. The original struct with the single method makes no sense. Module-level functions and clear DTOs are definitely the way to go. We can split log file creation from task spawning. This ended up here somewhere. And we need to question if the log lines vector is actually something that we need, or do we care about sending a log message and displaying it somewhere? Then we can also use channels for that to an entirely different process. Little word about LLMs, the stuff that confuses me so much. They can produce the worst code you've ever seen, but also so can humans. If you use LLMs for writing code, be the driver, steer the conversation, refer to literature. This works so well. So a friend of mine said I have a very weird relationship with copyright infringement because I was actually happy that an LLM read all my books and now it produces great code. So maybe they're right. So refer to patterns, double check, and question before you decide. So asking questions is always a really good idea to get to the right result instead of giving just instructions. Let's talk about humans. So we were here to help a person with the async code. The original author was very appreciative of my response. This was great. But they were also stuck in old thinking, which led to a very long conversation on trying to flip their mind around, which also basically led to this talk. I think they continually lost their minds in conversations with me. But in the end, we both grew. And with that, finally, for real now, thank you and goodbye. Thank you for coming to my talk. If you have any questions, I'm here.
All right, thanks a lot. We have about 10 minutes, so at 25, we're going to have Rose's talk. If you want to switch to another room, there's an opportunity between now and sort of the end of the question. So yeah, who has a question for Stefan?
A bit tangential, but we have code that uses channels to communicate, but it evolves with time, and sometimes we need other channels from in the opposite direction, and sometimes other channels that propagate some other data, and it becomes a spaghetti. So what are your advices on how to manage that?
This is a really good question. So this can get really, really messy if you need to communicate back and forth. I usually have some sort of proxy or messenger that knows which tasks are being hooked up there and can broadcast the message. This works really well. The sender pattern also works really, really good, where you say you know who to call and you give them a way to call back through a one-shot channel. This is also a really, really good pattern that works very, very well, but it totally depends on the situation that you have. But usually what I end up with is some orchestrator task that knows how to connect the dots and has all the channel management done. And it's not ideal for many situations, but in a lot of situations it works really well.
Thank you.
All right. Anybody else with a question? No? Oh, yeah. Over there. 3, 2, 1. Oh, nice one.
Thank you very much for your talk. You said that tasks should end. And I just remind about a previous application where we had this pattern that we spawn a couple of tasks and wait for them at the end of main, but they were like endless living and, you know, react on something or sync every 10 minutes, whatever. Like, I want to know what's your opinion on this pattern or how you would do it.
Maybe those tasks are too big. So I don't have any insights there, but if you say they wait forever on something or they check every other second or so, what's the event that you're waiting for and design around that event. So what really helped me in designing those tasks is to see, I'm actually writing synchronous code. I just have those breaks where I can intentionally let some other task doing the work, but I don't focus too much about all the parallelism or asynchronicity. And this makes my tasks very, very small. So they get tiny and very flexible, which also means that I have the potential to use those pauses much, much better. And always extract something where I need to wait or respawn or rethink something outside of the process where I have one place where I can do that. Orchestrators. Sorry.
Thank you.
Cheers. Does anyone else have a question for Stefan? Okay.
If you have any more questions, I'm outside. I'm happy to talk to you. Thank you very much.
Nice. Thanks a lot, Stefan. Everybody, please take their seat. We're about to start. And please, these chairs, super comfy, don't fall asleep. Super important, because it is my honor for the second time to introduce our Grandmaster Tetris player, Rose Peck.
Thank you.
Working on CAD software using Bevy. Take it away.
Hello. My name is Rose Peck, and I work at the Foresight Spatial Labs making CAD software, computer-aided design. And today, we are going to be talking about all of the surprising challenges with properly doing unit handling in real-world CAD software. Specifically, I'm going to be talking about how and why the units of measure crate, UOM, isn't quite enough on its own. When I say unit handling, to be clear, I am talking about real physical units of measurement, feet, inches, meters, tons, and so on, and being able to properly convert between them. But before we get ahead of ourselves, I do want to say explicitly, I actually really like UOM. It is a fantastic library. While the title of this talk is literally true, in that UOM is not enough on its own for a real-world application, we are not going to be dunking on UOM today. I do apologize if you were looking for a roast, but you will be going home unsatisfied. Okay, so let's talk about unit handling. Why is unit handling important? Why do we care about this? And I'm not going to waste your time with this. We all know why unit handling is important. We've all heard the Mars Climate Orbiter thing, and if you have not heard about it, congratulations on being one of today's lucky 1,000. They crashed a climate orbiter into Mars because a piece of software messed up its units. Suffice to say that if you are dealing with units in a real engineering context, mixing up your miles and your kilometers can have very real-world consequences. So we care about this a lot. So let's talk about CAD, or computer-aided design. This will be easiest to see if we have an example. So let's say I'm working on a design package that helps mechanical engineers lay ductwork inside of a building. Every building needs to push around air for heating, ventilation, and air conditioning, and somebody has to figure out where all the air tubes are going to go. So if I was writing DuctBuster Pro to help engineers with this task, I might end up with some code that looks like this. We have a struct for our duct that stores an origin, length, and radius for each duct segment. And we've also got some methods on our struct that help us calculate both the total air volume inside of the duct and the position of the duct's endpoint. In a real application, these would probably be much more complicated, but this is sufficient for demonstration purposes. As you can see, this example does not have any unit information whatsoever. We have things like positions, lengths, and diameters, but we have no idea if these are in meters, centimeters, cubits, smoots, or even one of those weird imperial units like inches. Fortunately, here in the Rust ecosystem, we have access to the UOM crate, which should let us add unit information pretty easily. You just slap some UOM on your code base, and now you can support units. This is one of the many examples of UOM being awesome. You can just replace the bare F64s that we had before, the bare floats, with the appropriate UOM types like length, and everything just works. Even our volume calculation just works. These length and volume types handle all of the unit conversions for us. And they are even zero cost. Our struct hasn't gotten any bigger than it was before in terms of memory footprint. To complete our example, when we construct our updated duction struct construction, if you will, we specify what inputs our units are coming in as, and we also specify what unit we want our output volume to be. And you can see us doing that here. When I make these lengths in centimeters, I have to say that they are centimeter lengths. They're not just numbers. And then when I get the volume at the end, I specifically say that I want to get it in cubic inches. And everything just all works out. As a result of all of this, regardless of what unit system the user wants to put in and what unit system the user wants to get out, we can just handle everything fluidly. So this is awesome. Everything just works. There's absolutely no problems that are lurking in the shadows. The talk is now over. Thank you so much for coming. Yeah, not quite. I mentioned earlier that this duct struct wasn't very realistic. A more realistic example would look like this. This is the exact same code that we had before, except our origin is stored using the 0.3 type from Nalgebra, which is a popular linear algebra library. If we try to UOMify this like we did before, UOMify. Here, we, again, just replace our F64s with lengths, and everything just, never mind, we got a compiler error. Sadly, you can't just do this. You can't just stick a UOM length inside of an algebra point because it doesn't implement the correct traits. Nalgebra does export these traits publicly. You can implement them yourself on your own types. But because of orphan rules, we can't implement them for UOM, and UOM and Nalgebra don't have any interop for each other. And honestly, I'm not sure that they should. Nalgebra is a general-purpose, super generic linear algebra library. There is no reason for it to care about a thing like unit handling. And there are ways to work around this problem. You can work around orphan rule limitations using wrapper types, but the issue runs deeper than this. For example, consider this API from Perry. Perry is a 3D geometry and collision detection library, which would be very useful if you're trying to fit ductwork inside of walls. This distance function from Perry calculates the minimum distance between two arbitrary shapes, and we can see that the returned distance is an F32. What unit is that in? I don't know, man. Whatever unit your inputs are in, I guess. This isn't even an orphan rules thing. Handling units here would essentially require us to add an alternate API to Perry that includes UOM support. And we can even go further than this. What about databases? What happens if I want to store my data in any existing database software? Postgres isn't going to be adding UOM support for me specifically, no matter how much I batter my eyelashes at them. And this is the main problem that I actually want to talk about today. UOM works fantastically if you control your whole stack end to end, but this just isn't always realistic. Like, maybe if I had the resources of Autodesk, I could just hand roll all of these linear algebra and math and database libraries myself, making sure that they all have exactly the feature set that I specifically need. But I don't have the resources of Autodesk. As a result, many actual applications look like this. There is a portion of your code on the left that you control, where you can just UOMify everything. And there's a portion of your application code that you don't control, Nalgebra, Perry, Postgres, and so on. And in that portion on the right, you probably don't have any static guarantees about units. As a result, there will always be some API boundary that sits between these two chunks of code. And this is the important part, you can be intentional about where that boundary is and what it looks like. You control the API surface that sits between these two worlds. Congratulations, this is actually an API design talk now. So when you're working on a real unit system, there's actually two things that we need to decide. Firstly, we should be intentional about the API surface that exists between our UOM code and our non-UOM code. And secondly, we need to figure out what we're going to do in the parts of our code base where UOM isn't accessible to us. After we've entered the world of, say, Postgres, how are we going to handle unit information there? And this is a true engineering problem in the sense that there is no right answer. There are just trade-offs. The right answer for your application might not be the right answer for my application because you and I have different needs, even if we are both writing CAD. So let's talk about some potential solutions, and we'll talk about their pros and we'll talk about their cons. I'm not going to be going over every possible solution here. I'm just going to try to highlight the main ideas. So solution one is to use wrapper modules. This is a very natural solution. The core idea here is that we're going to write a thin wrapper layer around all of the external libraries that we want to use. That wrapper module then exposes a UOMified version of the original library's API, essentially adding the UOM support that the library originally lacked. For our Perry example, that might look something like this. We've basically just implemented our own public API, but we handle the UOM conversion at each call site. Inside of the wrapper, we convert our inputs into a unitless representation, we run it through the Perry function, and then we convert the result back once the internal code is finished. One convenient thing here is that it doesn't super matter what units we convert to and from inside of our wrapper function as long as we are consistent. If we feed Perry meters, then Perry will give us back meters. So long as we're using the same unit on both sides of the Perry call, we are good. Kinda. There are numerical stability concerns here, but we do not have time to get into it, so we're just going to ignore that part. So there's no numerical stability concerns, everything's fine. The main benefit to this wrapper module approach is that basically all of our code lives inside of UOM, and if we do this correctly, we can basically pretend that we live in a world where everything has UOM support. As a cute trick, you can even add a custom linter rule that forces people to use the wrapped version instead of the originals. The main drawback of this approach is that you have to maintain these wrappers for, checks notes, every external library that you use. there is also a second drawback, but it is a lot more subtle, and to understand it properly, we need to talk about auditing. In some domains, the precision requirements are actually extremely tight. Common examples here includes gas pumps and electricity meters, where the exact measurement off of the pump determines the price that the user has to pay. But this also comes up in industries like healthcare and pharmaceuticals, where messing up dosages can have deadly consequences. If you are working in a domain like this, then there are usually legal requirements around unit conversion. The exact laws and standards are going to differ between jurisdictions. I am not a lawyer, but to give you a taste, a common requirement is that you have to have a clearly documented paper trail for every unit conversion that your software does. These rules also often require that you have robust testing for every unit conversion, unit testing, if you will, and that you clearly communicate if a conversion ratio or conversion method ever changes. There are even some situations where, because of the precision, you are not allowed to convert units at all. This is the other main drawback to using wrapper modules. If you work in a domain that has any of these requirements, then auditing becomes much harder for you to fulfill. You have to track down every single one of these call sites across your entire code base and clearly disclose them. And you'll often need to do a lot of testing if they ever change. That doesn't necessarily matter for every domain, but that's kind of the point I'm trying to make. Every solution has its pros and cons, every domain has hidden challenges and requirements, and you need to think carefully about what your domain actually needs. So let's talk about another set of trade-offs in solution 2. It's all UI conversion. The core idea here is to push our API surface as far forward as possible, and we handle all of the unit conversion in the UI and in the input and output layers. Whenever we get input from the user, be that something that they typed into the program in the UI or some input file, we always convert it into a single known unit system, like metric. Then the backend does all of its math in this known unit system. All of our internals are just metric. Whenever we want to display or export data, we can then convert it back into the user's units right before it's shown to them. We essentially push all of the unit conversion to the edges of the system, and all of our internals get simplified down to a world where the units just always work out. The main advantages here is that our conceptual model becomes really simple. Most of your code doesn't actually need to worry about units at all. Unit handling essentially becomes a problem for your data processing pipeline, and it is not really an engine problem anymore. Additionally, if you have to worry about things like auditing, that becomes somewhat easier, since it's usually easier to enumerate your UI touchpoints than to go digging through your entire backend for every time you use a math library. The drawbacks are somewhat obvious. Most of your code has lost the nice static guarantees that IOuring would have been providing you. Like, sure, we say that the backend is entirely metric, but there's nothing that proves that the backend is entirely metric. The other drawback is that because you're always converting on input, you're always converting. In domains with really strict precision requirements, looking at you, defense industry, you might not be able to get away with that level of conversion. As a fun fact, this is what IOuring actually does internally. Whenever you construct a IOuring type like length, the data is converted to the base units of your current unit system, which is usually going to be the SI base units. So when I construct this length in inches, IOuring immediately converts it to meters, and then it does all of the math in SI internally. This also means that, like I mentioned before, if you are converting on input, you're always converting, so any system that uses IOuring is going to be doing some kind of conversion on basically all of the values. Again, this is fine in most domains, but there are some ultra-high precision domains where even that level of conversion is not acceptable. So what do we do in that case? That brings us to solution 3 that we're going to talk about today, where we seek to minimize unit conversions as much as possible. In this system, you basically cannot use IOuring at all, and you have to store everything in the units that the user gave you. And you'll also need to store what the unit was that the user gave you so that you can convert it if you ever need to. Then, in these systems, you must either mandate that all units are in the exact same input space, often through some kind of project-level configuration setting, or you must allow inputs from multiple unit spaces, but then only convert them when absolutely necessary, usually warning the user ahead of time whenever you do so. The obvious advantage here is that you are minimizing precision loss in an absolute sense. The user can be confident that if they give you a number, you do not mess with it at all unless you absolutely have to, and even then you only do it with their permission. The downside is obvious. This is a really big pain. And sadly, that is all the time I have for today. There are so many complexities in this domain that I did not have time to get into, and so many other solutions that each have their own trade-offs. I tried to give you a highlight reel of the most interesting ones, but I could easily spend an hour talking about all of these. And IOuring is an important player in many of them. But it can't provide its strong static guarantees everywhere because there are lots of external systems that simply don't support it. And there are also some things that IOuring can't handle because it had to make its own design decisions and trade-offs just like we did. So have you figured out what this talk is actually about yet? This talk isn't about units. I mean, it is about units, but this problem is a lot more broad than units. This talk is about FFI, and interop, and compiler internals, and serialization, and all of the times where we have to deal with external systems and where we have to lose our strong static guarantees that we normally get with Rust. It is a hard problem, and it is all about finding the right API design and the right trade-offs. Thank you for your time. I believe it's
Thanks
time
a
for
lot,
questions.
Rose. And now it's time for questions. Let's see. Ooh.
No one? Nothing?
This is impossible.
Thank you for the talk. I was wondering, for these high precision domains, did you also experiment then with arbitrary precision number representations to avoid that?
Yes. So depending on the domain, and again, this is going to vary somewhat, but there are some domains that actually require that you use fixed point. For example, if you work in defense, I don't work in defense, but I know people who work in defense. If you work in defense, it's actually a pretty common requirement that you have to use fixed point for all of your math. Fixed point precision gives you essentially a specific amount of static precision as opposed to floating point, which is a variable precision system. This is because in those domains, even the floating point drift that you get from doing normal math, which is normally negligible, they find that unacceptable. So they will legally require you to write all the software in fixed point, or in some cases they will use arbitrary precision systems as well. This is one of the many challenges when you're working in defense, but there are other super high precision industries where that can come up too. I wrote on my blog, you can see the link there, there's a supplemental addenda post that kind of goes along with this talk where I talk about some other fun details that I couldn't fit in here. One of the domains where this comes up is GIS, or Global Information Systems. When you have to deal with coordinates on the sphere of the Earth, they also have really, really high precision requirements, and so you can't just do whatever you want with floating point. So yes, this is very much a consideration. I didn't really talk about it too much in this talk because I didn't want to get into the underlying representations too much, but this is a very good question and a good point.
Nice, thanks a lot. Anyone else with a question? I think we have time for one more. Or does everyone want to have lunch? Oh, here in the front. Last question. 3, 2, 1. Whee! Oh no! Almost had a terrible accident.
You okay?
Thank you for this excellent talk. My question regards units that are not necessarily set, so you always know that 1 inch is exactly what a certain number of centimeters, and it won't change whatever happens on Earth. But sometimes you have units that needs to be converted dynamically. For example, this. And how would you handle that?
So this is a hard problem. This is another hard problem that layers on top of the existing hard problem. I guess my cop-out answer would be it kind of depends on exactly how the units are changing and what the dynamic evaluation needs to be. So for example, one thing that you'll see sometimes is that certain units are actually not standardized, despite the fact that they sound standardized. For example, the ton is a unit that we're all familiar with, and it's actually 3 units. There's the metric ton, the imperial short ton, and the imperial long ton, and they're all called the ton. And so you sometimes need to be really clear about which one you're actually talking about. But there are also things that change over time. You did mention GIS, and this comes up in GIS context as well. One of the challenges with mapping the Earth's surface is that the Earth's surface moves. What they do in GIS, and I'm not a GIS expert, is that essentially they update their standards every some number of years. So they'll have like the 1984 version, and then they'll have like the 2006 version or whatever it may be. And they're essentially just entirely different unit spaces. And so then you'll have explicit conversions between those. There are also other interesting situations where you do need to evaluate things dynamically. In those cases, I don't think IOuring can really help you. There is one that I've had to deal with where sometimes people will give a unit as density, and then sometimes they'll give it as an inverted density. They'll use specific gravity instead, which can't really be handled by IOuring because it's like a dimensional analysis system. And so in those, you usually just kind of have to write your own custom handler that exists outside of the IOuring world. And again, depending on which of those you need in your application and how many of those and where they need to be, that might influence where you place your API surface. Maybe you try to stick that inside of the IOuring world but kind of hide it, or maybe you just accept that it's going to be outside of the IOuring region and you'll just have your own custom handling for that. So I guess it depends.
All right. Thanks a lot, Rose. And with that, it's time for a lunch break, which will last until 2. So you have an hour and 15 minutes to get lunch. It'll be downstairs. If you have any allergies, it's not the bar on the left, it's the second bar, the one in the middle. And there's a Women in Rust meetup in the raised area, in the lunch area. And it's open to anyone who's interested. Thanks a lot, and see you back here at 2.
And welcome back to the main track. After lunch, I would like to quickly mention our gold sponsors, which are JetBrains and Zed and Google. Thank you so much for sponsoring us. Now, we've just had lunch. How are we all feeling? Are we feeling good? Lunch was good, yes? I was just talking to Andrea, and we would like everyone to do a little bit of a wave, just to get everybody into, like, you know, a little bit active again. So can we start over there? Oh my God, that actually works. Awesome. Thank you, thank you, thank you. Right, so this is Andrea, and she is an assistant professor in programming languages at the TU Delft, which is a fantastic university. I went there myself.
Thank you.
And especially the programming language department is absolutely fantastic.
Thanks.
She also told me that she works on static analysis tools for undefined behavior, actually analysis tools, both static and dynamic. So that's not going to be part of the talk, I think, but you should definitely ask her about that afterwards. Take it away, Andrea. Please give it up.
Yeah, it's definitely no pressure in telling you how I'm teaching something that you collaboratively created and maintained. So yeah, lessons learned from using Rust as a tool for software fundamentals. And to give you a context about this, Software Fundamentals is a homologation course for a master's program on computer and embedded systems engineering at TU Delft. We mostly, for this homologation course, we mostly take electrical engineering students. And our goal is within 10 weeks to equip them with the necessary software development techniques and concepts such that they can work closely with CS students, with students that have a preparation in computer science. So I joined TU Delft a little bit over a year ago. This course was already designed when I joined, and it was designed by Jana and Vivian, who are here helping us organize this. Thank you, Jana and Vivian. Also by Koen and Soham. And as a disclaimer, the presentation is not the result of a user study, so I'm not going to show charts and numbers with regards to students. It's mostly a collection of personal experiences and observations from doing this class, for teaching this class. Right, so I like to start my lectures, whether it's in compilers or software fundamentals, with a very simple question like, for example, this one. And I would like to ask you all, what is programming for you? And take a couple of seconds to think about that. What was your first experience? What language did you use? What did you find challenging? What was easy? What was exciting? So I'm defining programming as a translation problem for all of my courses, again, whether it's compilers or software fundamentals. It's a translation problem where you take in a specification and you translate it into something that the machine can understand and execute for you. And the specification can come in many forms. It can be formal or informal. It can be ambiguous if it comes in English text. It can be graphical if you have some diagrams, or even executable if you think of tests as specifications. And then code has different properties. Code is precise. We want code to be maintainable as well, and ideally safe too. And then it becomes, you also want the translation to be correct, of course, and this problem becomes a translation of many interpretations to something that's very precise. So that's how I defined programming. Now, our path to equip the students with the necessary technologies and the necessary knowledge for programming is the following. So we have 10 weeks, as I was mentioning. We start in the first week, in the Hello World week, with very small textbook kind of assignments. And those are just few lines of specifications. So the specification there is like, you have a vector, implement perhaps a push and pop method for these vectors, not more than 2-3 lines of specification. However, by week 5, they have actually already implemented an individual project that takes in raw data from your smart devices, such as electricity, gas, and so on, and translates them into a visual representation that's easier to be parsed by the human eye. And that has a specification of about 12 pages. And from there, we move on to work in groups. And for the next 4 weeks, the students are actually implementing a Nintendo emulator, where the specification is actually a few dozen pages. So with this kind of a setup, the students learn to navigate specifications from something that's very precise, kind of, and very concise, to something that's very ambiguous, and it might contain more information than actually required to solve the certain task. Right, so what's software fundamentals then? So what do we need to teach students in order to be able to get to perform these tasks? A number of few things. So we want them to learn how to work with different kinds of abstractions. And if you attended or remember your PL courses, you might remember a number of different sorts of abstractions there as well. Like if you just want to do basic coding, you might just make do with Python. However, if you want to introduce type system, you might go to something like OCaml or maybe Java. Then if you want to abstract the data in control, functional languages do a great job for that. Then if you want to go to a little bit more low level, C does it pretty well as well. Or if you do compilers, if you want to teach compilers, you might reach out to C. Java, OCaml, Scala is pretty good as well for compilers. Now, I talked about correctness of translation and safety. You might also want to teach them a little bit about formal reasoning. And for that, normally, if we have a formal reasoning course, we have a number of very good proof assistants as well as verification languages. Algorithmic thinking is slightly easier in terms to the software we are using, because we don't care so much about the properties of the language as long as there's little friction. And then there's system understanding, where it depends whether how close are you to the hardware, whether you want to make any sort of trade-off between performance and abstraction. And then finally, we want them to be able to manage complexity, complex system. And for that, again, we have Java that has good encapsulation and the notion of objects. Or if you want functional and object composition, you might reach out to Scala and so on. So we have a number of different programming languages that can help us achieve the goals that we want. I guess there's no brownie points to guess what language we use, because that's why I'm here. We went for Rust. So we chose Rust because it allows us to go through all these stack of abstractions or different technologies and concepts. Now, why Rust? Of course, achieving low performance and control without sacrificing memory safety. And this is something I found in every research paper. It's true. It's an amazing result. However, we are in the classroom. And maybe a critic to our approach would be, you know what, Andrea, that's super cool in industry. But here you're actually teaching students, and we know that students learn from making mistakes as well, right? You have a seg fault, you have a data race. Don't they learn from mistakes as well? To which I respond, oh, they will learn from mistakes, because the compiler is giving you all these but why moments for, like, when it rejects code that you think it's perfectly reasonable at first sight. And the cool thing here is that the students interact a lot with the compiler. They communicate a lot with the compiler. So the compiler becomes a little bit like a free TA for us, a teaching assistant for us. OK, let's say maybe I convince you with this argument. There might be another argument. Namely, isn't Rust too complex to be used in a classroom? To which I say Rust is complex, but its complexity can be turned into a case study to actually support learning. And I'm hoping that I can convince you about that with the next few slides. And the reason I'm showing a cauliflower, which actually is a broccoli in this slide, will become very obvious, I hope, soon. All right, so I kind of structured this presentation into benefits of using Rust in the classroom and certain challenges we had as instructors, but perhaps also for the students. And I'm only going to focus on abstraction, formal reasoning, systems understanding, and managing complexity, since algorithmics doesn't impose that many restrictions on the language. Right, and I'm starting with the first abstractions, lots of abstractions in Rust. So if you want modularity, the combination of traits and generics is fantastic to give you a concise code that's very, very modular and generic. Then a cool thing is that iterators, so they learn about iterators, they compile to loops. So even before learning about loops, they can actually learn how to iterate through different collections. Then generics use monomorphization, again, gives you a very concise code. And of course, zero-cost abstractions in Rust are really nice because it allows you to do a little bit of verification with no runtime overhead. So to give you an example, I really like how readable the code on the top is, the one that we write using the iterators, because even without me telling you the specification, you can kind of read what it's doing. You have a vector, you iterate over it, you just filter out all the even numbers, and then you just square those and return the sum. So you can read what the code is doing without actually knowing what loops are. So this is kind of nice because in functional languages, you always start from focusing on the what before you actually understand how to implement that. So we can leverage that in Rust as well. Next thing about abstraction, which is probably one of my favorite things, it's its type system that doesn't only describe the shape of the data, but also information about ownership, aliasing, and so on. So, and that's kind of nice. So we have the low-level reality as well, where it allows us to manipulate pointers, and you have the move and the copy semantics. Here's the copy semantics in action, where you have these numbers. So it's very easy to kind of show it, but like the students with just looking at the code are a little bit confused. They come maybe with a little bit of math background as well. So to support the learning and explain how copy semantics works, I'm actually using this sort of representations where I'm actually showing an operational view as well of what the effects of every instruction is over the memory. So then, of course, you can say, hey, you know what? If you want to actually obtain the same thing, but like the same effect, but when you start using heap, the same thing doesn't really work anymore. And to do the same thing, you actually have to clone. And then you show the effect of what happens if you clone and you're using the heap. And that leads us to motivate why Rust was designed with the move semantics in mind, because because you want to actually be very careful with how you manipulate your memory, because these are students of embedded systems that they are going to work with bare metal, so resource usage is very, very important. So you motivate move semantics like so as well. And you can move on, and the nice thing is that the type system, introducing the type system and these constraints, allow us to think about resource management at the same time. Now you move on and you show the same example, but now again using a vector and using references. So instead of move, now I'm just creating a reference here. And I'm doing the same with a mutable reference now. And you know what's nice about this? Because I can also explain these examples also with copy and move semantics. So it's at this point, we actually discover patterns where the copy and the move semantics both have the same effect, but they are used for different things. One is how do you manage your resource for showing ownership movement, and the other one is actually helping a little bit the type system with exclusive mutability access. Right, here comes the first challenge. By introducing all these things and motivating each new design choice because of something that the previous one doesn't allow you to do, it slowly becomes a Rust tutorial, which, like, we have plenty of amazing Rust tutorials. It's not our job to come with another one. Our job was to kind of share what the concepts of software fundamentals are using Rust. So the challenge was that here I'm kind of forced to introduce notions before the students have actually seen the problems that those concepts are supposed to solve. And as a result, without careful manipulation here, without careful design, we can gradually shift towards discussing Rust-specific mechanisms instead of focusing on the software fundamentals. So to mitigate that, how we designed the classes, at least, is that in the first lecture, we just do a crash course in Rust, which is tutorial-like, but we focus a lot on what you can do and what does it mean, what you're allowed to do and what you're not allowed to do. And then subsequent lectures just focus on concepts one by one. And we do that by also introducing tension and some friction between the examples, like I showed earlier with the clone, right? That's not too nice with like you're using too much memory, what can you do, and so on. So introducing tension works, and then repetition, as much as possible, repetition of concepts. Now, the next one is on system understanding and managing complexity. What we all know, which is something super cool, is that Rust operates without a garbage collector. So here I am using, again, my favorite three-liner program to explain how that works. So initially, I'll just say, you know what? The compiler automatically inserts a drop for you when the owner goes out of scope. So for them to understand this, they will have to understand the notions of ownership, variable scope, references, lifetimes. They will also have to understand that VAC is not just a primitive, but it's actually a data structure. And we learn that data structures implement behaviors, and they learn how they do that with traits. And then finally, we learn that Rust follows this concept almost everywhere, which is the RAII, and then by doing this, we actually, okay, it's complex. They need to learn a lot of things to understand why Rust is garbage collector free, but this gives us actually a very nice case study in system design and complex management. So they learn how with proper language design, you can actually have a very nice orchestration of features that allows you to have features like garbage collection freedom. The challenge is that all these concepts are very, very interwoven. So it's difficult to introduce them one by one. And here's another example. What happens in this example, so you have a main function and you create a box with a string in it, and then you print that string, and then you print that string again, but indirectly through a user-defined print method. So what happens here? We taught students that, you know, don't be scared of box. Box is just a data structure. So at this point, they are looking at me, okay, box is a data structure, and you're dereferencing a data structure here. How is that possible? Well, it's possible because box is a smart pointer, and you have to believe me that that's possible. And let's just say that they will believe me, but then I'm going to this one here, where I'm taking a reference to a box, but the print method expects a slice. And then they are like, but you just told us earlier that, you know, there's no implicit coercion going on, yet there is something happening here. So you explain this by explaining that, you know, there is this trait, which is called deref, and there's some implicit coercion going on actually for everything that implements this trait. So the compiler doesn't really need to know smart pointer. Okay, I'm in this case now. No, it just needs to know I implemented the deref. So that kind of, it's complex, but it kind of clarifies how Rust does it, and it's a clear separation of concepts. So Jana also observed this. As I mentioned, Jana actually designed this course for the first time, and she also struggled with the same things. Okay, how do I order things in a way that actually follows the constraints of all the assignments the students have to do, but also explain them in a principled way where it makes sense and you build one on top of the other. So this interwovenness is something that's kind of challenging in the classroom. And the way to mitigate is that I'm promising that whenever I'm saying and I'm giving a magic technique that just works in Rust, I'm actually going to give you a closure once we have all the concepts and I'm able to explain how this actually works. So there needs to be a trust from the students that at some point we will get back and close this loop of knowledge. Right, and here's formal reasoning as a benefit. So as I mentioned, in Rust, the data type, the type system comes with memory safety guarantees, which is fantastic for someone who has spent her PhD working on a logic that's able to verify memory safety for a C program that's probably not more than 20 lines of code. So thank you, Rust. We can do now that at scale. And that's very nice for me, but it's also nice for students because I'm giving them these guiding principles summarized here. There are actually lots of other rules behind, but now they can actually do verification when they type check a Rust program, because when you're writing the types, you're actually writing some specification. You're just not writing just the types, but also describe the footprint of that, the memory footprint of that method. And when you're doing type checking, you're actually doing verification at the same time, which is pretty cool. And here's this one principle, which is that a variable, so every value has a variable that's called its owner, and there can only be one owner at a time, right? So if we look again at this three-liners Rust program, what we can see, it's actually not very obvious that there's only one owner. I'm doing this move. They learned the move semantics. They also learned operationally what's happening there, but it's still a little bit like, I feel there is a small gap, visual gap between looking at the code, looking operationally, and then what the type system is doing. There's a little bit like there's a mismatch, a visual mismatch between the local syntax we see and then the global invariance that the Rust enforces. And the mitigation for that, I actually introduced a third visual or a third aid there, which is I'm adding a mental model of what ownership and borrowing means. So at this point, they will have three tools to work with. You have the code, the syntax, you have the operational model, and you have a mental model. And I'll explain that mental model by mentioning one thing. We have in Rust a lot of different things to denote length or life or liveness. So first of all, the most basic one, we have scope. So I'm denoting scope with these rectangulars here. And I'm denoting scopes of variables, and that simply defines is related to variable validity. And then you have liveness. This is also a concept attached to variables, but it's more, it's in relation to the permissions that the variable has. So the permission is, the variable is live if it has ownership permissions. And then you have the non-lexical lifetimes that are attached to references. So there's yet another notion of lifetime. So they need a way to distinguish between these two, otherwise it just becomes overwhelming. So I'm using these diagrams, which were inspired by reading some research papers of Ralph, which I've seen here. So Ralph used this to explain stack borrows, which was great. I took that idea and I used it in the classroom, and I expanded to explain the other concepts as well. And now, with this four principle, I can actually explain reborrowing pretty nicely, because you just follow this stack principle, and you can have multiple mutable borrows as long as they follow this, like the reborrowing and the stack principle. And it becomes a little bit easier to manage, at least in the classroom, it becomes easier to manage the explanations if you're using this. Right, there are alternative visuals. So all those operational semantics things that I've showed and I'm showing in the class, those are proposed by Will Crichton. And he also proposes another visual for showing how permissions flow through the programs, namely this. So it turned out it's quite good for students to debug and understand what happens under the hood with the type system. But in the classroom itself, I still prefer this representation because it gives me a little bit more space to talk about the concepts and not focus so much on the precision. So just giving intuition while sacrificing a bit of the precision. So there are further benefits of having Rust, using Rust in the class. I think it's quite nice that it has very good support for testing and error handling. There are lots of public materials for those students that want to dig a little bit deeper. And I also find that the community is quite responsive and supporting for whoever gets into this. So thank you, community. Right. Rust provides abstractions, to sum up a little bit, that are both an aid, because it allows us to focus on what when we just start Rust, but they can also be a challenge because of the interwovenness. The type system encourages us to reason about programs in terms of invariance, which is quite nice to start to form a little bit the mind towards, like, our mind towards formal reasoning. And then the compiler guardrails are initially a little bit of a friction because seemingly correct programs don't compile, but it turns into a blessing because we have yet another TA always present with the students. Some pedagogical lessons. It's challenging to figure out the exact order of concepts to be introduced, but this, like, promising to always come back and like complete the cycle, complete the magic, give a closure to the magic actually helps. The three lenses approach works really well as well. So you show the code, you show operationally what happens, but also a little bit of a mental model. And then it's extremely satisfying to see formal methods working, like you code and you do formal methods at the same time and you do it at scale. And finally, I think Rust is a case study for managing system complexity through language design. And we are in good company because apparently human brain synchronizes better with that which is complex than that which is simple. And I've heard this said by a cognitive neuroscientist, Carmen Simon, which explained about how to navigate complexity and how complexity can be overwhelming and it can be a cognitive overload if not properly managed. And she explained some techniques on how to do this. And the more I was listening to her, I was like, oh my God, this is Rust. This is definitely Rust. So she was explaining how to manage and how to navigate complexity through the idea of fractals. So what are fractals? Are these objects that have a certain property. And no matter how much, like how much you magnify into that fractal, what you see still has that property. So to give you an example that's something very relatable, you see a tree has, you see the branches of a tree, you look at a branch, the branch has further branches, and it goes like that until the smallest branch. Or you go to the market and you see the broccoli. So the head of broccoli actually has the shape of a broccoli, and it's formed by many smaller broccoli buds. And these smaller broccoli buds have more baby broccoli buds, and so on. So everything is a broccoli. And she explains that by giving these supportive aids where a student or whoever touches a complex problem doesn't just go in and out of that problem with a lot of randomness and a lot of chaos, but they actually go following certain rules. And no matter at which abstraction level you are, you see that you're coming back home, you're coming back to the same rules over and over again. So I showed earlier about the move and the copy semantics. Well, it was used to implement, it was used for efficient memory management, but it was also used to enforce mutual exclusive borrow, right? And then we saw maybe the RAA is another good example where you're using it to allocate and deallocate memory automatically without using a garbage collector. But that's also present once they start learning about concurrency, and you have all these concurrency primitives that implement lock and unlock, and you just don't see it, but it happens. So it's nice that there are a lot of different patterns that come over and over again, regardless of which concepts we are introducing. And I find that's a very nice lesson in language design, and perhaps also a case study for students to learn about complexity solved in an elegant way. Right, so why Rust? in our case, it was a great vehicle for introducing a lot of different concepts without the friction of having to change the programming environment every time I want to go to something else. And so I will not feel guilty if you think about Rust the next time you buy a broccoli or a cauliflower. Thank you, everyone.
Thank you, that's amazing. Any questions? Let's light the room so we can go and have a look. Oh, the box. We're looking for the box. There's 3 to 1.
Hello. Particularly in the case of people who are learning Rust as their first language, is there any particular part of the language that you find they really get hung up on, perhaps in comparison to other languages?
Oh, great question. So I think the first roadblock is the memory, the ownership, and the aliasing model. I think that was kind of a little bit my job with software fundamentals, to make sure that's not a roadblock, and the ownership and aliasing model is definitely properly understood, so that they like, it was so nice in the class when I started to show the visual models, where you could see literally their shoulders becoming detensed. They had a light on their face. Oh my God, yes. Now I understand it, but it can definitely be a friction at the beginning, it's intimidating to start talking about this as a beginner. And perhaps the next one is concurrency, and then the next course after mine deals with trying to unpack concurrency such that they are able from week 30 to actually build a controller for a drone using Rust.
Nice. There's a question over there and over there. 3 to 1. Nice.
Hello. I'm so proud of myself for catching the block. Thank you so much for this talk. I work at a nonprofit focused on creating people who come from non-technical backgrounds how to program and to make art with code. And a lot of the work that we do has to do with creating a simpler environment for people who are like visual thinkers to get into computational thinking. A big question on my mind is, as we start doing a major quantity of work that is in Rust, is how do we get people who come from that background to use our tools and then to one day also start contributing to the Rust code base. And so a big question is, how do we get them to a place where they're able to understand these concepts that are not exactly easy?
Good question and difficult question. I think it's very difficult in general, as I kind of experienced as well, to work in a class with very diverse backgrounds. So some students have done some C++, some have done some Python or some Java, but it's very difficult to find the common language so that you could speak on the language of everyone. The students already had a beautifully structured mind being used with electrical engineering, so I had to use that structure that they had to start thinking about software as well. So I think there's no one solution fits all. I think it's very much dependent on getting feedback from the students as well, trying to see, because if you're too slow, you're also going to lose some of them, I feel. So it's just getting a lot of feedback, and I'm trying to be in contact with the students. I'm trying to be as approachable as I can during the class as well. So I get this feedback constantly. Okay, like for example, with the mental model, I didn't bring that at the beginning. I thought initially just showing the code and the operational view is sufficient, but then I saw they were still struggling. So I'm like, okay, how to explain this? And then is when I remember Ralph's paper, which clarified some concepts for me, which I was already a researcher in this topic. So it's just trying to collect as much, I guess, collective knowledge as possible and apply it accordingly.
Nice. Any other questions? Oh, yes, of course you.
I don't want to speak for everyone, but I mean, I like Rust because of how it's different from other languages, but for students that are learning Rust for the first time, can you tell if they can appreciate what they're getting from Rust? Because like they never had to go through the pain of doing everything in C.
tricky question. Right, so most of the people here have learned Rust by having an intrinsic motivation. Our students had to learn Rust because we asked them to. So the motivation is a little bit different, where because we ask them to, it's kind of on our side, and we take accountability to guide them slowly through this. And we guide them not just with lectures, but we have quite a number of TAs. We have 8 lab hours per week where the students can just go and discuss these concepts. So we try to provide as much support as possible because we know this is not necessarily what they wanted to do. They came here because they wanted to do embedded systems. Yeah.
There's a question over there in the back. Just up the stairs.
Thank you. At the beginning of the talk, you were talking about like teaching through frustration and like not giving the students every tool, every technique, and just showing them, oh, this is hard, and then here's how you can make it simpler with the language. Have you thought about doing that specifically with iterators? Because you said instead of using loops, they can use iterators, and that's more concise. But you could also make it the other way and first teach them loops, and like, oh, the loops are complicated to use, a bit long, and then you can make it shorter with iterators.
Yeah, right. So for iterators, I actually try to be as specific and clear as possible. I didn't introduce much friction, but I still had to introduce a bit of friction there as well because you have an eager and lazy iterators. So those are concepts that are very common in functional language, but if you come from imperative style, I'm like, oh, what's eager and lazy now, and why do I have to know about this? So there was a bit of friction there as well. But where I used friction more was perhaps more with the aliasing model, where I showed at some point the boxes. Look, this is like, if the boxes are non-overlapping, you're in a good place. If they are overlapping, you're not in a good place. So they learn, and I showed them examples by using the boxes. So they are happy. Okay, I'm understanding. Then I show reborrowing. That doesn't follow the same rule because it has to follow the stack, and only then I show the stack. So I'm kind of using emotions there where they are like, I'm getting it. Then I show an example where like, you didn't get it with a reborrow. But it's nice because this sort of friction forces them to think a little bit deeper on the why. Yeah, so emotions I think are important, but definitely check those emotions because you don't want them to be overwhelmed and just give up. So it's always with a little bit of help and guidance there.
Okay, we got time for one more question. Well, actually, no, let's do 2 more questions. Fair enough, you had your hand up for so long.
Okay, no worries. First of all, again, thank you for the talk. It really has some nice reflections about me, in this case, teaching Rust and that kind of stuff. The question I have, because actually I'm now talking about a fundamentals course and that kind of stuff, what Rust actually also has taught me, for example, that it does have primitives not only to create safe programs, but also actually to teach us the better principles of software engineering or programming in the language. Have there also been ideas in this case to use Rust to do that? For example, things like you called resource allocation initialization, single responsibility principle, and that kind of stuff, that actually nicely projects on modern software engineering.
Right. Thank you for that question. I actually ended my all the lectures, like the very last lecture was on design patterns. So after they knew almost all the concepts that I needed them to know for that for this course, we went into design patterns and analyzing the design patterns, where do they appear in solving problems? Why, like, you know what? Already so many people went through this problem. No point for us to go again through it. There are solutions for this as well, and we can also learn from such design patterns. Not always we have to go through that problem or experience that problem to learn. So in that sense, I think covering the design patterns at the end was kind of a nice closure to to the entire lecture. I wish I would have insisted a little bit more on design patterns for embedded systems, but maybe I'll do that next time. Currently, I just refer to design patterns in general overall.
All right.
Thanks.
And then one more question. No? No, it's okay? Okay, so give it up for Andrea. Thanks a lot.
Thank you.
All right, we got 5 minutes, and then we'll have a presentation here by Cliff Waffle. You. Nice. Okay, so I would like to introduce the next speaker, which is Cliff Waffle. He's the author of Learn Rust the Dangerous Way, Unsafe Rust for C developers. And God, I should have known that, okay, when we started. That's great. And he did and there's like 2 Rust operating systems, shipping and commercial products, Hurits and Lilos. Yep. Nice. And he works at Oxide Computer Firmware and Tooling. Take it away.
Oh, how do we full screen the browser? Sigh. We might just have. I'm F11ing, yes. You can see I work with computers for a living. I agree with you. There we are. Now we're at the end of the talk. Wouldn't be the same talk without errors, right? Hi, thanks for coming despite this. I'm Cliff, and I'm way out of my comfort zone right now, actually, because I really like to come with solutions. I sort of do this because I like to be able to say, like, you have this problem, I had this problem, here's a way of thinking about it, or a way of framing it, or a ready-made solution that will take your problem away and make your life better. And that's kind of why that's my thing. And that's not what I'm doing today. So this may not be the talk you're expecting, but I think it is the talk I should give. So today I've actually just come with a bunch of problems. Problems that I've run into rewriting system software in Rust. And by system software, I mean operating system kernels are kind of the canonical example, but also bare metal firmware or other kinds of software due to resource or determinism restrictions winds up using the same techniques, like game engines are, I would argue, system software. These are the popular target for rewriting from C into Rust, or from Go into Rust, or C++ into Rust, but there are some recurring patterns. And it's weird to give a talk about problems I can't answer, but here's why I'm doing it. First of all, if you're in the audience, you're probably going to hit these same problems, because I keep hitting them, so we can bond over it, and that'll be great. But also, I think we need a better language for talking about these issues. They're sort of design patterns. I mean, they, in some cases, literally are design patterns that are valid in other languages, but are hard to produce in Rust, and maybe not the right thing to be doing. But knowing how to spot it and when to stop and back away can be very valuable. And finally, I'm selfishly giving this talk because I would love it if you came up to me afterwards and told me, like, oh, Cliff, you obviously didn't see the Flubel crate that will just solve all of your problems. You should go download it, and then I don't have to give this talk anymore. So I'm doing this to start a conversation. I'm going to try to leave time for questions at the end. And please come up to me afterwards if you want to talk about this stuff, because, well, I don't know what I'm doing. So just to set expectations, there's a bunch of issues people run into around rewriting system software that I'm not going to cover. We're not going to talk about build systems integration. We're not going to talk about C++ ABIs. I'm not going to do incremental conversion module by module. These are all really important. But frankly, you don't want to listen to me about this. There's other talks on that. These aren't really my bag. My bag is low-level implementation stuff, the stuff that happens inside a source file and how you reason about the source code itself. So all of this stuff is kind of out of scope. So what's in scope? So I put out a call online for suggestions for problems people were running into to help me write the talk. And thanks to everybody that submitted stuff. But I went through all the submissions, and I marked them up, and I coded them, and I categorized them. And I started out with a talk that would be far too long, and it just kept getting shorter. And a lot of the problems collapsed into the same set of problems. So I'm not going to cover them all today because I don't have time, but kind of a lot of them can be, I mean, arguably, I could do this whole talk with one slide, which is this slide. So thanks. No, this is not really a joke. So like by aliasing, what I mean, and if you came to the last talk, you got this described, but by aliasing, I mean when you have 2 references to data, and you follow those references or follow a path through them, perhaps indirectly, do you wind up at the same backing memory in the computer, in which case you have aliasing, or do you not, in which case you don't have aliasing? Rust has opinions about aliasing that are somewhat unusual, particularly in a systems programming language. And these opinions are important and are responsible for a lot of Rust's guarantees. but also can make things really difficult because it turns out systems programmers spend kind of a lot of our time managing aliasing, whether we call it that or not. And so I want to walk through some patterns that are difficult to port primarily because of aliasing. And there's a longer version of this slide that only fits because I made the letters longer and because I don't have standards. So most non-trivial systems programs spend a lot of their time managing arbitrary cyclic graph structures, but we don't call them that. And so we don't use graph tools on them, and they're hidden and partially specified. And that may sound very vague. So let me use a worked example. So this is a very simplified version of the process struct you'd see in a Unix kernel. Very simplified. So a process in Unix can have a parent process, which is usually the one that spawned it and is the one that gets notified when it crashes or something like that, to simplify. Here we've got a reference from a proc to its parent proc. It's a something pointer, made up smart pointer. Maybe it's a box or an arc or something. Ignore that for the time being. I'm not using references here because to write a reference here with an ampersand, I would need to use an explicit lifetime. And I'm actually trying to avoid doing that in this talk because aliasing is distinct. The issues we run into around aliasing in systems programs are actually distinct from, related to, but distinct from the issues with borrow checking and lifetimes. So pretend this is a magic smart pointer where we can ignore lifetimes for the time being. I'll come back to it. We have a potential cycle here. You can store a pointer to the proc in the proc, a cycle of 1. You can make a more complicated cycle where a thing is a child of its parent or its parent is its own child. And most Unix kernels go to some lengths to try to maintain invariants that prevent this, but the type level doesn't prevent this. So from the compiler's perspective, or from the perspective of a programmer who's really tired and breaks the invariant, this can contain a cycle. But there's other cases where we deliberately create cycles, like you have a process that wants to join a wait queue. So it has this wait state thing that has next and previous links. And people who have done the Learn Rust with entirely too many linked lists tutorial, which I highly recommend, will recognize this. This is an intrusive doubly linked list. This pattern is pervasive in system software, and it's pervasive for a very good reason. It's one of the only data structures I can think of that has like constant time insert, remove, linear time traversal, and storage that comes from the things that join the list instead of being pre-allocated. So like this data structure is popular for a reason. It's also really difficult to express in safe Rust or even unsafe Rust, having done it incorrectly myself. So I would argue, you could say that these are hard because of lifetime, but I think the problem is that these doubly linked lists are cyclic graphs. Even sometimes an empty one is a cyclic graph. And that means that cyclic graphs are difficult to express in Rust. We have tools, but none of the tools are totally general. So one of the tools we have, one of the tools we have is to not use pointers or references at all. So in fact, this is how version 7 Unix did it. Rather than a pointer to a proc in the parent, you have the proc ID. This could be an integer indexing a table, say. And then when you want to operate on it, you've got to pass the proc table and the ID. And you pass these around, and the proc table might just be an array or a slice of proc, but the function that's using it needs to take the ID and use it to index the table. So people call this a lot of different things. I've been calling it the collections and keys approach to representing graphs. And taken to extreme, you can basically eliminate the use of pointers in a program. But is this sufficient? And it's not really. It can fix a lot of things, but there are issues with collections and keys. So if you have multiple collections, like multiple sets of entities, for example, you can confuse the keys to the different collections. You can take just like you can take an index for one vec and accidentally use it to index a different vec. And that won't get you the results you want, typically. You have to pass this reference to the collection, to all the functions, which is not great. I mean, it's survivable, but you are kind of starting to write your own memory allocator, which might have not have been what you were expecting to do today. And because you're writing your own memory allocator, you're sacrificing some things. So you've made this thingy that kind of acts like a pointer, the indexy thingy, and it has no lifetime attached or anything. So you've given up your compiler support for managing lifetimes and borrowing. And in particular, if like process 12 is removed from the table and you're still holding a proc ID 12, you're going to find out about that when you go to use it, which is kind of a late time to find out about that. And then while we've given up the compiler guarantees, aliasing is actually still an issue with this approach very quickly, because eventually you do need to turn that back into a reference by dereferencing or indexing it. So, and I'll go into that particular point in some detail in a minute, but I also want to include a bullet that keeps coming up, but I put it in small letters because I don't believe it. It's possible that you will see reduced performance by passing around indices in an array and doing repeated array indexing, but I've personally never had a case where that was the performance problem. If you have that as your performance problem, I kind of want your problem. But all computers are different, so it's possible that you will run into a performance problem. Keep it in mind and always measure. So, on that last bullet that I said I'd come back to, so this process of passing around a collection in keys kind of just changes the nature of the aliasing problem without eliminating it. So let's work through an example. So here's a process structure. I've added some fields to it to make it a little more fun. There's a memory map and some file descriptors. And our function takes an exclusive reference to a slice of procs. That's our proc table. It could be more complex than this, but let's go with this. So when we go to write that function, this approach works until we need a second function. So this is usually how I have wound up tripping when I try to use this approach. We borrow one of the processes from the process table as P, we do some things to it, and now we want to operate on a different process using this other function. Other function also needs a proc table and an index. Problem is, we've borrowed the proc table. So we can't pass an exclusive reference to the proc table to this other function because P is borrowed, and the borrow checker yells at us. In this case, you could maybe release the borrow and let P go out of scope and reborrow it later, but in the general case, particularly if the lifetimes wind up overlapping, this is hard to do. So this is part of the reason why I don't think this shape is a solution, not in the general case. Part of the problem is the exclusive reference. The exclusive reference makes us prove at compile time that we're not aliasing the proc table, and that's fundamentally what the borrow checker is mad about here. We can punt this to runtime using refcell or mutex, but I'm using refcell because frankly it's easier to understand. And you can run into these problems without threading. So with refcell, we could put all the procs in the proc table in a refcell, and now we can pass a shared reference to it, and we can mutate it, and that's great. Sort of. It's great, except that we now get a visit to Panic Town. So both our initial dereference of the proc table using the ID to look up a process, we use borrow mute, which can panic. And maybe it won't panic, but in our other function, we can compile this call to other function because it's a shared reference. We can pass it while one of the processes is borrowed. But other functions type says, I want a slice of all of the ref cells of the procs. And if one of them is borrowed, is it expecting that? Is that part of its contract? It's not clear if it can handle that. Is it using try borrow? We don't know. So taken literally, other function needs all of the procs. Really, we've just replaced a compile error with a potential runtime landmine. If ID2 and ID are the same value here, we have a panic. So that's not great. It can work, but it's not great. So, okay, maybe a ref cell on the proc isn't right. Maybe we move the ref cell down a level. Maybe we move the ref cell all the way down to the memory map entries and the file descriptor state in the process. Now we have a lot of ref cells. The likelihood that you're going to have the same file descriptor borrowed twice is maybe lower, so we've made the landmine much smaller. But it's still a landmine. We still have a potential for panic that we can't express in the type system. So this is not great. And also, we're doing systems programming, so we probably kind of care about memory usage and things. And refcell, the way it's implemented, adds a usize pointer-sized field to everything that you wrap in a refcell. It's not unusual for systems programs to have very carefully designed, densely packed arrays of structs that are laid out just so. Putting a refcell on each of them here screws up that layout and may make the difference between meeting your requirements and not. So, like, this is also not a fully general solution. And you can go down this rabbit hole pretty far, but I think we can just safely say that, like, getting the granularity of something like a refcell or a lock right is hard and requires some application-specific knowledge. This is the same sort of thing you see in interpreters with, like, the big interpreter lock versus more granular locking, or lock-striped data structures. Like, this is not a Rust-specific problem, but because Rust requires things like a refcell or a mutex to mutate shared data in cases like this, it comes up a lot more often in Rust. One of the things that performance weenies like myself often reach for in situations like this is called structive arrays. So structive arrays, well, it's more or less what the name says. Rather than a big array of procs, each of which has fields, we have a collection of arrays, one for each field. So each of the arrays contains a uniform type. It might look like this. So here's our useProc function, the contrived running example. It wants to operate on procs, but it turns out it only cares about the memory maps and the file descriptors. So we only hand it the arrays of all of the memory maps and all of the file descriptors. They're all allocated next to each other in memory, say. So this can work. This has some issues. You're going to need to use that ID to index both of those slices, say, to get out the memory map and the file descriptor for the same process. That's fine. What if those slices aren't the same length? Because we can do that now. Like, we could have 16 procs that have memory map entries and only 8 procs that have file descriptors, and we couldn't do that when we were using structs, because each struct gets all of the fields. So that's not great. The upside of this, though, is that frequently by slicing things up like this so that you're not borrowing a whole proc at a time, you can switch back to using exclusive references and make your borrowing problem slightly different. So this can cut down on your overhead and sometimes is a right trade-off, but like sometimes. I don't think I've ever actually stuck with this in a program after really leaning on it. And so I have this list. Why is this a good idea? It's cool that like in a separate module, you can add a field to proc because proc isn't real and doesn't have fields and there's just a bunch of arrays. So you can add a new array anywhere you want. It's kind of neat from a code organization perspective. And as I pointed out on the last slide, it may let you reason more better about your aliasing and granularity of your ref cells and stuff, but only if you pass all of these things separately, because the moment you take references to all these arrays and put them in a proc or a struct and start passing that around, you've reconstructed your I borrow the whole thing problem, and you can wind up back in aliasing town. This also makes storage and allocation a lot harder, and we care about storage and allocation in systems programming. You've now got a bunch of different arrays to manage instead of one, and particularly if you want things to be able to grow cheaply at runtime, you're probably not using a slice. You're probably using something more elaborate, maybe some kind of fancy tree structure. I don't know. Well, now you've got like 16 of those instead of one of those. Is that better? I don't know. It depends on what you're doing. And then this point I lit on before is like those different arrays can now have different shapes, which introduces a new way your software can fail at runtime, which is not great. We don't like software to fail at runtime. Okay, so this doesn't really solve the problem either. So what if we just throw all of our code in an LLM and say, make unsafe Rust with no safety proof? But you wouldn't do that, right? We'll just use raw pointers everywhere. Pretend we're in C. This is fine, right? Or maybe just smart pointers. Maybe we wrap the raw pointers in a thing we make that's like non-null in the standard library. It makes a nice little API on a pointer, but it lets us ignore aliasing. Can we do that? So, sort of. The smart pointer thing is tricky because Rust's smart pointers are inextricably tied to the structure of reference types in Rust. And it's mostly due to the deref and deref moot traits. This is deref. This is what like box implements to let you get read-only access to things. It makes a reference. Generally speaking, when you use a smart pointer, with the exception of non-null, which has its own thing, but like box, arc, these things, you do deref and deref moot, and basically they have a trick for turning into a reference. So by using one of these, you inherit all of the aliasing requirements implied by a Rust reference type. Okay, so not smart pointers then, fine. We're going full C, we're gonna write lots of asterisks, and everything is gonna be raw pointers. Can we do this? Well, sort of. It used to be really hard. So this is what you used to have to do. This is wrong, to be clear, but here we have a pointer to a proc, and we want to get a pointer to its parent field. Easy. Normally with a struct, you'd write dot parent, and you're done, right? With the pointer, we have to do this little dereference, re-reference, unsafe dance, and this is partially for ergonomic reasons. So Rust, as an opinionated language, likes to use ergonomics as a cudgel to lovingly bludgeon you into doing the right thing. And this is not the right thing, and it takes more letters to type. And I don't actually think that's a coincidence. But this is also wrong because of the ampersand moot there. It used to be to get a reference to a field from something pointed to by a pointer, you had to go through a temporary reference, which means even though that's temporary, you have to meet all the aliasing guarantees. So this is wrong. However, in the past couple of years, we got even more letters we can type. We can type raw after the ampersand, and now more letters means more better, and this is approximately correct. You can now get a pointer to a thing in a struct. What you can't get is a pointer to an element in a vec. I forget if you can do an element in an array, but like there are corner cases. There's things you have to look up. This is subtle and hard to get right. So my recommendation is do not go full C and attempt to just use raw pointers everywhere. It is not going to end well yet. Maybe more ergonomics will be changed here. I'm a little concerned. Rust is already very complicated, but maybe. So that kind of sucks. None of these solutions are perfect. So I promised I wasn't just going to talk about aliasing, so I'd like to stop talking about aliasing. Instead, the second sort of grab bag topic is I want to talk about global variables. C programs, system C programs in particular, we like global variables. And there are some reasons why we like global variables, and there are some reasons why Rust kind of doesn't like global variables. Like, you can declare global variables in Rust, but again, they have ergonomic challenges that mean you probably don't want to. And it's worth talking about why. This is going to be a bit of a pastiche, and I apologize, but for the purposes of the talk, the reason why Rust doesn't want you to write globals is because you can just reference them whenever. Like if you have a static or static mut, which is usually how a global manifests in Rust, and it's called myvar, and you have a function where myvar is in scope, you can just ampersand myvar all you want. Make as many references as you want. You can make exclusive references. You can make shared references. You can make them both at the same time. You can make 2 exclusive references. And I'm sorry, but I'm talking about aliasing again. I tried. But really, this isn't going to be about aliasing. This is just like, I feel like the issues with globals in Rust are mostly aliasing. So I think that's fine. I agree with Rust on this. So why do I want global variables? We've all been in the code base or heard stories of like the code base made unmaintainable by overuse of global variables where you can't reason about it. And every state is changed from everywhere else. And so why do I find them attractive? So here are some nice things about global variables. Number 1, they're easy to find in a debugger. That might seem really pedestrian, but like this is table stakes for a debugger. You don't even need dwarf to find a global. It's in the elf file. It's at a fixed memory address. It's great. Although a lot of people don't use conventional debuggers anymore, but I'm from Oxide and we definitely have the debugger disease. So like this is really important to me. Statics are also, if you're in an application where you can't put things on the heap for determinism reasons or don't have enough stack or are trying to limit maximum stack depth, you need to put something in memory somewhere. Static is kind of your third place to put a thing. So static memory winds up being really useful even if you don't use globals per se. So you can use static in ways, and I have a blog post about this, without making a global per se, but bear with me for a moment. Here's the thing that I keep tripping over that I don't know how to fix. Globals can help you reason about the code using local reasoning, which is counterintuitive because a lot of the problem with globals is that you can't reason about them by only looking at one place in the code. Let me show you what I mean. Here are 2 versions of our useProc function. The first is the way it would be expressed in something like a Unix version 7 kernel. We take a process ID and we turn it into a process struct by touching a global procs table. The global procs table. There is only one global procs table because it's named procs, and if we had 2 of them, it would fail to link. That's kind of nice, actually. The second one here, we take it as an argument. We get a procs table. Is it the procs table? Well, I don't know. This does make it easier to test. Being able to hand in an arbitrary array is nice, but you can also hand in nonsense. Like you can make your own nonsense proc table. You can take a slice out of your proc table and hand it in. So now process ID 1 is process ID 8, and all hell is breaking loose. And you probably don't want to do this, but you can if you're not careful. So with the global, you don't have to worry about this because you can look at the function and say it is touching the proc table. It also counts for cases where sometimes you need to find a data structure in a table asynchronously, like an interrupt handler may need to figure out which process is being interrupted by looking for a thing in a global array. And it's really quite easy in a global. It's much harder if it's an arbitrary slice reference passed on the stack. So I think my conclusion is like global variables sometimes, like they're not, they have a bad reputation for a reason, but I miss these properties of them. And when porting things from Rust, I often wind up taking a global table, replacing it with a not global table, and then having to write a bunch of docs to explain what thing you can pass and how to find the real table and stuff like that. So I feel like we could use better approaches to some of these problems. My overall conclusion is like, I'm still that guy that's running around rewriting all the code. Sorry, not sorry. And, but there are this class of rewrites that take more work than others. And well, I want to try to start collecting terminology for this. So I would love, if you have time, come up and give me your solutions, and let's see if we can make this better. Thanks.
All right, thank you, Cliff. Now I'm wondering whether there are any questions from the audience. There should be a little bit more light now, and then we can see. I can see the cat ears fine. That works.
Hi, since you mentioned talking about potential solutions, like most, this isn't going to be a full solution, but cell projection, allowing you to go from a ref of cell of object to a ref of cell of field. Mm-hmm. It allows you to, like the language doesn't support it super well yet, but it allows you to utilize plain old data type structs in a way closer to the way you might in C or C++, because basically you copy out the data to use it, mm-hmm. or you copy the data in to replace it, and everybody agrees that it could change because everybody can replace it, but it's always replacing it piecemeal.
Mm-hmm. Yeah, cell projection is one of those things like, what is it, the per field borrowing suggestion, where it could potentially help with this, and I'm also concerned about the level of visible complexity it might add to the language. But it might be the right thing, but it might be complex. So yeah, I agree. It's something to keep an eye on.
All right, any more questions?
Yes, hi. But when you were describing the approach of using indices to look up values in lists, that sounds very similar to ECS systems, like using game engines. So I'm wondering if that could be, patterns from that domain could be helpful to tackle those problems.
Yeah, so I mentioned game engines as an example of systems programming quite deliberately, and I have this idea that I haven't successfully been nerd sniped all the way into doing, but I really kind of want to write a real-time operating system kernel using an ECS, because they're so similarly shaped, and it might be a really bad idea, but I won't know until I trip over it. So yeah, the parallel is absolutely valid.
All right, we have more time if you want.
Surely I trolled someone else.
There, and there's also some people over there.
Right. One shape of a solution comes from the GC Arena crate. They have a very interesting solution to this problem of, okay, I have a cyclic data structure and I want to do mutations on it, but I also don't want it to mutate underneath me, like unexpectedly. And they do a huge amount of very, very dirty invariant lifetimes. You would love that, I think. And if you can somehow marry that and operating systems, I would laugh heartily.
Yeah, so I actually cut a bunch of slides on arena allocators because it became clear that I was just so mad about aliasing. And sorry. The GC Arena uses the same trick that, if there's any Haskell nerds in the audience, it's similar to what the ST-monad does with coming up with an existential type to keep you from crossing things from different domains that shouldn't be crossed. They do it with lifetimes. It's clever. It's hairy. I don't understand it. I'd like to, but yeah, something like that might be interesting. Arenas are another thing that are really popular in C that we have a hard time with, to be honest. But yeah, something like that accessible to systems programmers, ideally without a heap, would be amazing.
Perfect. I thought some questions over there. If you could throw it sort of in that general direction. There we go.
how many of these global problems are for programs which need to run in a multi-threaded setting?
Ooh. So globals are a lot harder in a multi-threaded setting because aliasing is a lot harder in a multi-threaded setting. And if you don't have aliasing, it's kind of hard to get race conditions. And that's kind of one of Rust's insights, really. But globals are hard to not alias. So a lot of these problems do become much worse in multi-threaded contexts. But in a systems environment, we often have concurrent situations that make this sort of problem occur even if you don't have threads. For example, bare metal firmware will get interrupted by an interrupt handler that's running in the same address space on operating systems other than Hubris. And that is effectively a preemptive thread appearing in your own process. On Unix, you've got signal handlers that do the same sort of thing even if you never touch threads. So yeah, you're absolutely right that those problems become much worse in multi-threaded environments.
The question was also more about if the solution space can be for just single-threaded areas.
Yeah, it can be. I mean, so for example, we use the portable atomics crate on Hubris to do singletons that can be locked, except that Hubris is inherently single-threaded, so we actually just stub out the critical sections, and locking it takes no data or compute. So some of these things kind of degenerate in a single-threaded environment. Unfortunately, there aren't actually a lot of single-threaded environments left.
All right, there's up there first, maybe? And then we'll go down to the front here.
Hello.
Oh, the catch box got lost.
We weren't recruited for our manual dexterity, I think.
So you mentioned being worried about the complexity of Rust, like when cell projection was mentioned. We shout out for the field projections talk because they're going to talk about that. Can you elaborate on that? What are you
I feel like the
more
previous
specifically
speaker would
worried
be more
about here?
qualified. So one of the things that I have the privilege of doing is taking people with relatively little Rust experience and dropping them into firmware. And we've got a lot of successful developers in Hubris that had no embedded experience and not a lot of Rust experience, and that's cool. But it also exposes the fact that teaching Rust is hard. I mean, is it harder than other systems programming languages? We could probably debate that. Is it harder than Python? Yes. So where do you draw the line? All of these features are great, but I used to write C++ for a living. And so I've got trauma. And I loved a lot of those features, but I also never saw anyone use all of them. And thank goodness for that. And I don't want to get there. So it's more of a vibe thing of it's important for us as a community to keep an eye on how complex to understand we're making the artifact that we're asking people to learn. And whether adding that new thing is going to push it over some threshold to where it becomes argument-dependent template lookup, to use an example from my past. So I don't have a firm answer. It's more just a I'm worried, right?
Makes sense.
All right, there was a question all the way in the front here.
Hi, a great talk, by the way. So this is more of about the borrowing issue that you have. There was a paper released 2 years ago about Ghost Cell, which does a separation of the permissions from the data by creating a token that has the lifetime on it, and you pass the token around. And that's how you provide whoever is borrowing the mute. You get the mutable borrow, or if you want to just borrow it for reading and stuff like that. And I'm wondering if you've looked at that or.
I haven't, but I pulled up the paper. Thank you. I'm going to have to go digest that.
There's somebody that's already implemented it as well, which has they've done the W linked list using the Ghost Cell, So you can look at that. His name's, I'm probably going to butcher it, but it's like Matthew M.
Okay.
I don't know if you know him. He's done quite a few things, but yeah, if you look him up, he's done the Ghost Self or double linked list.
Thanks.
Yeah, just to comment on that, it does create some problems with tree-shaped data because I looked at that for UI stuff, and yeah, like it's really nice, but I think for tree-shaped data the pattern doesn't quite work out. Although I have an idea for something similar, but yeah, maybe we can get into that maybe after.
Cool, thanks.
Awesome. Yeah, keep us posted about that.
Yeah.
All right, one more question.
So I have one that is not about aliasing, which is that the invariants in Rust tend to be a lot more local in the sense, like, for example, you have a mutex. Oh, you're nodding, so I'm not saying something stupid. So like you have the simplest case, you have a mutex and you can only access the thing inside it. In C, you have a mutex that gives you access to this, that, and that other thing in the other module. Have you think about how to reconcile these two?
Oh man, I have a blog post on this actually, talking about my perspective on why Rust mutex is shaped the way that it is. I think it's called something along the lines of like comments aren't contracts. But yeah, this is a difficult thing we run into, and I occasionally see people when porting C code reach for mutex of unit, like a mutex that contains nothing, because they want to do a C mutex, but like don't, is the short version. It's difficult to reconcile because a well-maintained C code base will carefully comment which fields are guarded by which mutaces and will use them consistently, and that's great. And you can just read the comments and you can reconstruct it into Rust. But like, not everyone is curl, so like a lot of code bases don't have that property, and you wind up having to reverse engineer the concurrency constraints. So like, this is a good point. This could be a whole nother talk actually.
Next year.
All right. I think that's about the time that we have. Thanks so much, Cliff. Thank you. Please give it up for Cliff. And we'll be back with you in a few minutes with the next talk. Hello, welcome back, welcome back. Our next speaker is Amos, better known as Faster Than Lime. You might know them from, there you go. You might know them from their blog, YouTube, other online presence, and also the Self-Directed Research podcast with James Muntz, which I personally really like. And they're going to be talking about Facet. Take it away.
Thank you. Thought it was at the end, the applause. It's been over a year. It says a year, but it's been over a year since I and the community on the Discord and on the GitHub and on the internets in general have started working on Facet, and I'm super thankful to the organizers of Rust Week for letting me come here and report to you, how it started, how it's going, this kind of thing. But in order to talk about reflection, we have to start with derives. We love derives in Rust. Anything you want to do, there's a derive for it. If you want to deserialize some JSON into a struct, Surday's got your back. It has a derive macro called deserialize, which implements the trait of the same name. Really proud of that transition. And this is a good thing, right? People like that. This is like people come to Rust and they're like, oh, this is neat. I really like that. But it's just one behavior. If you want more behaviors, you might reach out for more derives. For example, if you want to debug print a struct, you might reach for the built-in debug, which gives you an uninspired rendering of your value, but it's useful. If you want to implement the display trait, you can go manual or you can go doc comment. You can use the display doc crate to do a doc comment. Did you know this crate? It's pretty neat. So we see a pattern, right? Every new behavior calls for a new trait. Every new trait calls for a convenience derive. I'm aware that we have bare functions. Do not, please. And derives are usually called implemented using procedural macros, unless they're built in. And procedural macros have garnered some criticism over the years, which I will sum up succinctly as, why is a pure AST transform shipped as a Rust source we have to compile and optimize and run and memorize, granting it full disk and network access, just in case? Which is a fair question to ask. And many people have tried to solve that one way or the other, and nothing is stuck so far. And that's not all. Like, despite solid, reusable bases like sin and quote, proc macros have to get a lot of things right. There's a high barrier to entry to making a proc macro. And even if you do make the best proc macro on Earth, you still have to break network effects. You still have to get adoption, right? You have to somehow convince everyone else to add support for your proc macros in their crates. And when they say no, inevitably, you have to add support for their crates in your crate. So Rust's orphan rules have created an ecosystem composition problem, right? You have to get all the crates to play nice together, but it's like YouTube. You can't break in anymore. Like you can't just do Minecraft on YouTube and get success. It's the same thing with crates. It's hard to break in. So as a workaround, some crates have started piggybacking on successful crates derive macros. For example, this is Surda Reflection, which uses the deserialized crate to implement reflection, which is the software engineering equivalent of like cutting up some newspaper bits to write a ransom note. I don't like it. But most of all, I think the state of affairs is a lesson in unintended consequences. Because I don't think the people who approved proc macros and said, like, you know what, it's a good start. It's a good stopgap. I don't think that they realize that they were laying the foundation for the future antitrust suit against Surda, the proc macro that cornered the entire market. However, the idea of many crates building upon a singular derive is, in my opinion, sound. We just have to kind of adjust our strategy. Instead of trying to turn our types into more code, since we're not able to predict all the code we're going to need, all the behaviors we're going to need, we might consider shipping data about our types. And that's exactly what Facet does. It is a derived macro, so it is full of sin, like the others, but it only adds an associated const named shape. So what is the shape of a type? It's a couple things. You can barely notice it in your binary size, don't worry. Name, offset, alignment, type name, type ID, declaration ID. What's the difference? Type ID, you have one for like a vec of U32 doesn't have the same type ID as the vec of U8, for example. Declaration ID, you have only one. How does it work? Don't ask. It's the location in the sources plus module path. Don't ask. I said don't ask. Representation, discriminant, variance for enums, type parameters, const parameters, which are not the same thing, of course. Attributes, doc comments. You can read the rest. So with all that information about the shape of our types, we can make a better debug, right? One that has color, one that redacts sensitive information, one that dumps vex of U8 as hex, like as bytes, which is really nice. But if we want to go further than that, we must be able to call the various trait methods on our types at runtime, which requires vtables. V for virtual is just a struct with a bunch of function pointers. And the trick is it forces the compiler to instantiate generic functions. For example, we have vec push in very, very dim gray down here. You have vecs of different types. You might want to like push a U32, an F32, whatever. Here for facet, we're forcing it to like generate all that code just in case we need it. And that ends up being a lot of code. Is the problem. I was kind of hoping moving from Serde, which tends to generate a lot of generic code and a lot of LVMIR and tends to be like show up if you try to profile your build, you're going to see Serde somewhere. And I was kind of hoping, OK, we're going to trade some runtime performance. Reflection is going to be slower, but for like better build times, because it's just data, right? It's not a lot of code. You don't have to optimize it. It's going to be better. I was wrong. This is a negative result that I have to report. This is what I'm here for. The build times are like, meh, like kind of, it's a wash. It's kind of same-ish, sometimes better, sometimes worse. We were right about one thing, though. Performance is worse. Runtime performance is worse. We were right about that. This was like 100%, which is to be expected from a reflection-based system, because you're not like walking through highly optimized code anymore. You are now walking through the structures. So by design, it is much slower. And that's a fact of life. You can do nothing to change that, unless you're willing to do a lot more crimes, of course. I have this RPC system. Well, I have like 7 RPC systems, but who's counting? Which has like forward and backwards compatibility. So it's like you're connected to a peer, and you're not negotiating which version of the protocol you both talk, right? They talk a version you've never heard of before. So you're just looking at their struct, and you're going like, OK, this field is optional. That field I don't know, but I can just ignore. And you're just kind of mapping. You're just creating a translation table between both. You can take that information and shove it into CraneLift, which is a just-in-time compiler. And if you do that, then you can actually beat Serde, because you have a lot more information than it did, right? So I'm pretty proud of this. I was hoping for some applause, please, because come on, this is great, right? You show that slide, you're really feeling good about yourself. But of course, micro benchmarks are always lies, especially the ones given at conferences, especially the ones that you haven't given a right of response to, right? Someone else on the other end of that benchmark should have a right to like spend 15 minutes and flip all those bars, right? But they didn't. But too late. It's recorded. It's live. I won. But they're all suspicious, right? By default, until proven innocent, they're all guilty. Especially that one. That 8.6x, you're thinking here, like, how is Rust C/LLVM losing against CraneLift and Claude, right? It doesn't make sense. It doesn't make sense. And there's a very good question. There's a very good answer for that, sorry. It's a gap in Serde. Now, can anybody yell what's wrong with this? What's missing here when you're doing Serde? Does the derive serialize up here? The vec view 8, you're doing post. Serde width, exactly. You're missing Serde width. So what's the problem? The one on the left is actually dealt as a sequence of numbers. And the one on the right is dealt as an array of bytes, which is very different. For JSON, not different. For message pack, different kinds of records. For postcard, it's just a performance issue, right? The one on the right is just a mem copy. The one on the left is just a manual loop. The performance difference is actually not that big. So it would be nice if Serde was actually able to like do that for us without the annotation, right? But that would mean you would have to specialize on the T in its implementation of serialize for vec T, which is not a thing in Rust stable and should not be a thing in Rust nightly either, because it has many issues. So is that what I did? Did I just cheat? Like I just forgot the annotation, whoops, because like we don't need it in Facet, and this is why we win. No, because what we're actually serializing is this, vec of F32. Which is a lot more fun, because even if you added width, you would have an adapter that then would see, OK, it's a vec of F32. Now what? we have a serializer. We have the same problem. We're generic over the serializer. Now we have to specialize over the serializer. We have to see, oh, we're serializing for postcard. Oh, then we can take the shortcut, right? And we can't do that, right? Because there's no array of F32 type in the 2930 types. Whereas if you're doing reflection, everything is slow, but at least you know the type at runtime. So you just have a match, and you can like, okay, it's U8, it's F32, it's whatever. You can do your custom stuff, and it's all good. And this is how, on this slide, if you remember, this is how we can detect that it's actually a vec of U8, and this is how we show a hex dump instead of something else. And this is how we won the race. Now, this is obviously not closing the chapter on performance. I can't just say, I made a JIT, I won, the graph is on my side, therefore, reflection is good, you can just use it. Because, obviously, shipping a JIT is not an option for everyone. But if you're shipping for Apple platforms, Apple's going to get really mad at you. If you're shipping a JIT in general, users are going to be mad at you because the binary is going to be like, why do we have an entire compiler backend in this small command line utility? It doesn't make sense. And the warm-up times, everything, and the safety. But even like without the JIT, just reflection in general, there are areas where a developer would be willing to like trade some raw performance for some better ergonomics, like test assertions. This is the default assert ec macro in Rust. You have to find the difference. You have to find the difference. It's the port. It changed from 443 to 281. Me personally, I prefer pretty assertions that there's kind of an enhanced textual diff on the debug output, and it's much more obvious what's going on. But my favorite, of course, is my own assertion library called rediff, which uses facet to actually do a structural diff. And you're just going to tell me, Amos, that's basically the same thing as the previous slide. You're just bragging about nothing. So is this one, right? Not a big difference. I picked the colors I like better. That one's much better, though, right? Because the text diff gets very confused. But the structural diffs is like, OK, health is still there. It's changed value. Admin is gone. Metrics is added. Pretty cool. And then, of course, you can do like the same trick, byte diffs. Instead of having 1 decimal per line, you have an actual nice hex dump with ASCII and everything. And then this has nothing to do with reflection. I just wanted to show confusables. This is an actual ASCII A in yellow on the left. And on the right, you have something that renders exactly like an A, but is not the ASCII A. Another natural use case for facet is Fig, my crate, which is kind of a fusion cuisine between Clap and Figment. So it's doing command line parsing. You get this nice inline help that you expect from any command line application, of course. But you also get an HTML version that just opens in your browser. And then you can search from there. It shows you everything, the defaults, the types. You can copy in your clipboard like environment variables. You can set to override some things. It's really nice. And just like Figment, it kind of keeps, it has layers, right? It's like config, environment, and CLI args, and it keeps track of the provenance of everything. So it knows, what you said from where. So you can, when you're debugging something in anger on Kubernetes, you would kill for this, just so you know. And then you get nice error reporting through IOuring. It's just all very nice. Oh, and you can export JSON schema, of course, because you have information about the types. So you can generate JSON schema, you get validation, you get auto-completion, you get docs on hover, you get default values, everything. But this is not just like stock, you just derive the macro. You have to actually put some arguments there, to put some attributes on your fields. And those are clearly not part of like the default set of facet arguments. They're clearly prefixed as args. How does that work? It works like this. I'm not even you could just read the slide. I'm just going to drink. So it's not a second proc macro, right? You're calling a regular declarative macro from your crate, and you're just declaring an enum, and you're like, config doesn't take anything, so OK. And then env prefix can optionally take a string. That's it. And then, how's the error reporting? I hear you ask. Very good. It's very good. This was really hard to make. Like, it looks easy. But if you look underneath, you're going to see a bunch of back and forth between macro expansions, and you don't want to see that. There are so many other cool projects that I wanted to talk to you about that are built on Facet. This is Facet IGUI, which lets you inspect and mutate values, at runtime with a nice GUI, as you would expect. I don't have time to tell you about Dibs, which is my semi-abandoned Postgres toolkit, which lets you define tables as Rust types. We've seen that before. Generate migrations, so that goes from one version of the code to the next. We've also seen that before. This nice UI, first Nobody did that. Also, you can make queries, right? You can declare queries, and you get autocomplete and everything. There's a nice editor extension, it works in Z, and it generates the SQL for the query, and it generates Rust to bind the results back into your Rust types. But again, it's slow. Who wants to use that? No, it's not. It's doing this as a build script, right? Because you can do reflection at build time. Why not? This is comp time. We have comp time at home. I don't have time to tell you that this is not actually a DSL. It's actually just a document language that I made because nobody accepted the pitch at the conference to replace YAML and TOML and whatever, which is also built on top of Facet for flexibility because it has weird concepts that don't really exist on JSON and other document formats. So yeah. And I don't have time to tell you about the language interop stuff that we have. You can generate a bunch of TypeScript types from your Rust types. This is not novel. We have crates to do that before. We had crates to do that before Facet. The novel part is you derive once, and then you have all of that stuff available to you once. Finally, Bevy Reflect. Many people have asked me, what is the difference between Facet and Bevy Reflect? And the answer is, I don't know, because I haven't looked at Bevy Reflect. I'm so sorry. Someone should, honestly. There's stuff going on in the compiler and the standard library. It's a nightly. Ollie is working on it. It has a different scope than Facet, which is both smaller and bigger. It's different. It's still in progress, but you can go play with it right now. It's in nightly. I don't have time to talk about all of this because I made a promise. I want to say before coming here, but no, I made a promise yesterday in my hotel room that I would bring the stupidest crate I've ever made and present it to you as a Rust Week exclusive. And if you think about it, Facet is actually pretty bad, right? I'm not sure I like it because it's a proc macro. We said proc macros are iffy. There's a bunch of problems with them. You can't do rever Rust enums. Why? Because in every other language, ABI means application binary interface. In Rust, it means always be improvising. Can't really rely on, It's a bit bloated. We said compile times are not great, binary sizes are not great. I didn't show you numbers. There's a reason, Weak adoption, not even 500,000 downloads. That's weak. And it's still not 1.0. I've tried. I'm who knows? Maybe it's going to change. Better not release 1.0. So I've been thinking about alternatives. And what if I told you there's an alternative that does not involve proc macros or any kind of macros, right? It supports all the representations. There's no vtables involved. It supports all of the crates released or unreleased. And it's already 5.0. I'm happy to present Bilbo JSON. Bilbo is a crate that uses Dwarf to do reflection. It's not the first. I discovered 3 years ago. Some folks from Amazon also did that. They called it Deflect, and theirs is read-only. So mine is much, much worse. Bilbo JSON works very well. It's the only, I think, JSON deserializer in Rust which does not have a generic entry point, right? It doesn't need it. It just takes an address. Because what it does is it loads the debug information, it unwinds the stack, one frame, it finds a local with the same address as the pointer, or the only thing of that type in the frame. It's complicated because the NRVO and everything. Let me please find the slide I was in. Whoops, we are here. And it finds its type and then the type's layout, and it does the serialization, right? It's easy. You have all the information, you have all the layout. Why do you need a derive macro? It's already right there in the debug information. Now, quick notes. There's no error handling. As you can see, it does not return a result. I kind of forgot, so please don't pass it invalid JSON, right? Just like C++, just be careful. Just, this does rely on debug information, so please do not strip your binary. Please be considerate. And you might be thinking, this must be crazy slow, right? We were loading debug information, parsing it. It's famously very complicated. If you think that, you have not been paying attention to my talk. Because thanks to just-in-time compilation, crane lift again, I'm so sorry. Bilbo JSON beats Serde JSON on all 3 classic benchmarks. By a lot! And this is my last slide, but I will say, I taught you to be, we already learned something today. I taught you to be suspicious of micro-benchmarks, right? All of these are probably lies. The big one, most of all, Canada is a lie. Not the country, the benchmark. And that's true. We're not doing the same thing as Stabilization for Canada. We are doing some things differently, which means it's not an apples-to-apples comparison. Stabilization is actually taking a shortcut, which means it's like 1 ULP off for floating point numbers, and we're actually doing rounding correctly, right? If we enabled the precise mode for Stabilization, it would actually be more like 2.4x. But I thought that was, so I just left it like this. But never trust micro benchmarks. That's it. That's it for me. My last slide. Thanks for attending.
All right, thank you. I think we're a little bit strapped for time, but we should do just one question, right?
Just the pressure.
Yeah. Who's got a question? I see one hand over there. Catchbox coming your way.
I'm scared now.
So there's a lot of stuff here that you've presented about reflection.
Yeah.
How would you suggest that the Rust project work on making all of this complexity unnecessary?
That's an excellent question. We don't need the next talk, right? I can just answer it for 20 minutes?
I think so, yeah, that's fine. We can go until the end of the day.
That's a good question. I think, so when Ollie started working on the Reflection MVP, I was surprised because stuff has happened around the Rust project in Reflection. I don't know if everybody knows. And also just I was like, there's this consensus? Like, you get permission to work on this? I was like, that's amazing. And also, good luck. Like, Ollie asked the same question. Like, do you have any advice? I was like, no. It's a messy design space. There's a lot of compromises. We went back and forth. And the reason it's not 1.0 is we went back and forth on like what to include, how to describe it. Like, do you describe it from how the compiler thinks about the types, from like what's useful as a user about the types? Do you let it be like driven by serialization, digitization needs, or like, it's complicated, right? And I didn't talk about it, but there was a lot of concerns about soundness. Like, if you are able to mutate things, you can violate invariants that are just not expressed anywhere except for the code. There are more open questions than there are answers right now. And I hear that the Reflection MVP is actually being rewritten from scratch. So I'm not the only one who can't reach 1.0 right now. So.
All right, thank you so much. If you have any more questions, I guess they can find you.
Yeah.
And with that, I think we're all dismissed for a little break. Yes. It is a 30 minutes break until 16:20. Give it a farmless.
Do you have audio? Yeah. Nice. Everybody take a seat. Thank you. We're almost at the last bit. We have sponsors. We want to thank them a lot for making this event possible. It's super nice to be able to do this in such a great venue and have so many great people with great organization. It wouldn't be possible without our sponsors. So the silver sponsors are Espressif, Infineon, and Oxide Computer Company. We want to genuinely thank them again for making this possible. And our next speakers, well, you get 2 speakers for the price of 1. It's Jack Huey and Nico Matsakis. Yeah, they've been working on Rust since forever, 2011, something like that. Wish them a warm welcome and take it away. Thank you very much.
So, hi, I'm Nico Matsakis. Yeah, I've been working on Rust since 2011. I think that makes it going on 15 years. Have done many different roles. Recently stopped being Lang team co-lead in favor of Tyler Mandry. I don't know if Tyler's here, and I can't see, but if so, give him a good handshake if you see him around.
I'm Jack Huey. Not 2011, 2019, but yeah, also been on the in the Rust project for a while, it feels like, and we're both, along with being project people, have also both recently been project directors at the Rust Foundation too, so hoping to give some insightful data and such today.
Yeah, we're going to talk you through, we're not going to talk about any of the technical work that we've been involved in, but rather about some of the work that has been happening, some from us, some from others, in and around the Rust project on improving our communication sort of within the project and to the broader world. So we'll start out with a little context, and I have to say I like how big this arrow is in this screen. Rust is growing really, really fast, especially lately, and it seems to just keep getting faster, right? The number of users, the number of companies, the announcements you see where such and such a thing was ported over or whatever else. It's been super cool lately.
Yeah, and it's, as Nico said, it's really not just users, right? Like it's companies, it's domains, it's, you know, industries. Everyone is using Rust, and, you know, part of the thing that we have to think about is how we scale this. Because as it is, maintainers are overwhelmed, right? Because more people are using Rust with more needs, and although there are some maintainers, right, it's still difficult to know what people need.
Yeah, certainly the number of maintainers hasn't necessarily scaled. But Jack, I am confused because I feel like open source is supposed to not have this problem. Because what's supposed to happen, as I understood it, is we're all scratching our own itches, we're all fixing our own problems. And so as the number of users grows, so will the number of maintainers. People will come in, start picking up things, and not only that, but they'll bring their expertise to the table, right? So they know about their domain. Maybe I only know about compilers, but you know, somebody who knows about whatever one of these other icons, whatever they represent, science or something, will come and bring science knowledge to the table. Isn't that how it works?
Yeah, you would think so, but life is more complicated, right? Because not only is it hard to scale contributors and maintainers with users, but the different industries and the different domains all have different propensities to scaling too. So some industries will do great with open source and be able to, you know, provide maintenance and contributions, and others won't, right? They're not open source by nature. And so finding the right way to balance these is a challenge, especially for like the Rust project, who has very traditionally been open source, right? And open source first.
Yeah, so that's kind of the theme, I guess. Because although I was making a joke about open source solving its own problems, it is also kind of true. That's the ideal that we're aspiring for, is can we get people to come and join as they adopt Rust, to come and help make it better, and not just make it better for everyone necessarily, that's good, but also make it better for them specifically. Because that way we know you're working on important problems, and we know that you're bringing the expertise in the areas that you know best and bringing it to the table. Right? And that's what we really need to have Rust grow in a coherent way. But it can be hard to achieve.
So let's start with a story, right? And you may know, if you don't, now's your time to know, that Rust for Linux is a thing. Rust is officially a second language in the Linux kernel.
I just want to point out, not even C++ is allowed in the kernel. Just C and Rust.
And I sort of wish that, the original title of this was just the end of the Rust kernel, or the kernel Rust experiment, and everyone freaked out because it's like, wait, what happened? So I sort of wish I could have put that title. But anyways, what I want you to notice is this is fairly recent. This is only December of last year.
And I just want to say, let's all just take a minute. This is pretty cool. Come on. Yeah. But did you know it almost didn't happen?
So the Rust for Linux project started back in 2021. And it didn't start in the Rust project. It actually started on the Linux kernel side, where Miguel and others essentially were proposing this experiment, right? And what's interesting is, although the Rust project wasn't originally involved, it actually didn't take that long before there was some open communication. And so Josh Triplett, who is on the Ling team, among other things, was very rightfully aware of this and was like, we should talk to them. And so Nico was organizing this cross-team collaboration fun time thing that we had. Don't ask about the name.
No, do. We can say it. Let's all say it together. No.
Anyway, so it didn't last forever, this CFC, whatever
CTCFT.
it is. That one. It didn't last forever. But one of the presentations was actually from the Rust for Linux folks. And so we had a presentation, they told us what they needed, and that's great, right? We had a happy relationship from there on.
Yeah, well, sort of. So that was in 2021. And they came and they talked. There's actually a recording. Might be fun to go look at it. But talked about what they needed, but it kind of stopped there, right? And in fact, in some cases, the interactions were even kind of negative. Like when I talked to Miguel, he didn't want me to tell you this story, but I'm going to tell you anyway. He was talking about how they came in and they were talking in Zulip, or I'm not sure exactly where, saying, hey, here's some of the features that would really help us for Rust for Linux. And they got some responses like, you kernel developers are trying to control Rust. And like when I heard this, I like spit my whatever I was drinking out on the table. I was like, whoa, no, we want them to come. It's okay. You can come control Rust. You're Linux. You can do whatever you want. But no, seriously, I mean, I don't know exactly what comment was made, but the point is like, and I don't know who made it, right? It might have just been a random person, or it might have been someone with authority. But either way, those kind of comments can be easily misinterpreted, right? And can easily turn people away. And that would have been kind of a bad thing. Now, luckily, they hailed from Linux. They kind of have a tough skin. This did not dissuade. This is a fairly mild comment. It was all fine. But this kind of brings us to a scaling challenge, right? So maintainers are overwhelmed, yes. One solution is to get more contributors. But there's this problem that can happen a lot in the Rust org where actually people want to contribute, but they can't figure out how or where or who to talk to. There's a lot of activity, but it's not clear what's your way in, right?
So what was useful and eventually happened, I mean, look at the date, right? This is 2024, over 2 years after that CFCT, whatever.
CTCFT.
That one. 2 years after that the project and the Linux kernel folks had regular meetings, right? And now and since then, we have this job on CI that makes sure that the Rust for Linux, the Linux kernel doesn't break when we ship it nightly. But 2 years, right? That's a long time to go without good communication.
Yeah, so the kind of behind the scenes thing there is a number of us, Tyler Mandry, I remember, Josh, myself, TC, I'm pretty sure, and a number of us were talking, and we're like, we really should create a regular meeting. And so we kind of set one up as a sort of ad hoc thing, at least to get started. But what we noticed as we were working on that, we would be going down these issues. And so like everybody basically agreed, not just in that group, but I think across the project, that of course it would be great to have Rust in the Linux kernel. And so when you talk about it at that level, there's no controversy. It's clearly important. They had assembled a list of issues that were blocking what they wanted. That's great. But what would happen sometimes is that when you actually drill down into any particular issue, it starts to seem like nothing, like a small minor feature request. Like they were asking for, can we have a null terminator on the file name in a panic location? Right, and why? Because they have to pass it to C code in the kernel. So actually it was kind of a big blocker for them. But you can imagine being on a team and reviewing this request and being like, I don't know, sure, okay, like I'll get to that. You see the PR and you think, yeah, whatever. I'll add it real soon now,
And that's really the third challenge, right? Is even when contributors want to join and get things done, they can't get their work prioritized.
Yeah, and this isn't just for contributors, right? This happens also in between project teams. I think Mara, I don't know, I'm sure she's around, but a year or two ago was raising to me, like, there's a bunch of ambitious libs team work she'd like to see go. It's blocked on some relatively minor Lang features, and the Lang team is too busy chasing shiny objects to do that sort of boring sounding work that actually would have unblocked a whole bunch of important stuff. Right.
And we have a solution for this-ish. We're still working on it, but as always, they're called project goals. So thanks, Nico, for this again. A few years ago, we started this thing on the project called project goals. These have evolved over time, as anything does, but the core idea is that you have, someone says, I want to do this, right? And I need somebody to review it. I need to know if I do all the work, if somebody's going to help. Yeah. And then they make a proposal. They say, this is what I'm going to do. This is why. Here's who I need help from, what teams. And nowadays, we have a good system where you can say, I need you to have a meeting, or I just need somebody to come review the PR. I need to know if this is OK. And then the teams that you need help from say, yeah, we'd be happy to. And this proposal process, this project goal, it can be project members. It can be new contributors. It could be members of a company that are like, we want to use Rust, but we need X, Y, or Z. And we will help, but we have no clue how. And so project goals give a way to do this.
It also helps address a problem I call the unbounded queues problem that I think is sort of endemic to open source, which is that a lot of what we do is receive requests. People open PRs, and it just kind of goes on your work queue, and you have no way to put a rate limiter on that, right? And direct it at the things that you think are most interesting. So the hope with project goals, similar to RFCs and other things, is sort of let's move some of that work up front so that the team can kind of say, maybe we would be happy to, or maybe this actually would be nice, but we're full up, right? There's a whole lot of other stuff we have to review this time. Come back next year.
And so, yeah, it helps put the work in context. But it also has another benefit, which helps with scaling, which is that now it helps people that would do the work have a clear entry point. And once they have the entry point, it helps them stay because they know how to get their work done and have people help. And so, for example, with the Rust for Linux folks, we currently have a lot of project goals that are in this situation where they have come in and they want to do specific things related to the Rust project, the language, the compiler, and now they can put their work in context. And this has staying power too, right? As I showed previously, for the last 3 project goal periods, there's been Rust for Linux project goals, and this year there's a bunch.
And this is exactly the conversion we were talking about, right? Rust from Linux went from asking for things that the Rust project would provide to being integrated, sort of combined, to just driving those things essentially independently, right, that they need, and making general case improvements to Rust. P.S., Jack, you didn't call it out, but Benno, who's doing this project goal on field projections, has a talk tomorrow. You should come see it. It's going to be cool.
Sorry. And so, yeah, that's one thing. But then as people get involved, right, there's this awesome thing Nico loves to talk about.
I do. Hold on. I want. Okay. We didn't work out who's going to say which slides, but I'm glad Jack gave this one to me because I like this one. What I wanted to say is there's the immediate impact. That's the upper right, where hey, progress is being made on priorities for the Rust for Linux project. That's great. But there's also this less obvious downstream impact where we're helping the Rust for Linux team be successful and earn esteem in the eyes of their peers and sort of sell the Rust project to the rest of the kernel, right? Because the rest of the kernel has got a lot of people who are somewhat skeptical of new things. And this is where this curve comes in. I do love talking about this curve. It's like the one thing I got from that book, Crossing the Chasm. I'm going to explain it all to you in one slide. You don't have to read the whole book. Basically, as things get adopted, in the beginning, you got a bunch of people who are excited about new shiny objects. They're easy to persuade. Those are the innovators, the early adopters. And then there's this bit of a chasm where you want to get to, regular people who just want to get their job done, but who are willing to do a new thing if it's actually better, right? And that's what they call the chasm, is kind of getting over this gap. And the reason it's kind of hard is because these regular people are a little bit skeptical of being bought into the hype train, And so what they really want to hear is other regular people telling them, no, for real, this is the real thing. And so sort of the only person who can convince a random Linux kernel developer who's used to C that they should try Rust is another Linux kernel developer, right? Like, you can't do it. And so that's why it's so important when somebody comes there and offers you an in that you take it.
And so going back to the issues, right? Maintainers being overwhelmed, can't find a way in, need to get your work prioritized. How we do this, we start with a warm welcome. We add on the project goals. We center the contributor, let them do the work. And this ultimately leads to a growing community.
Yeah, so this last point, center the contributor, I think it's cute. I like, what is it called? Alliteration. But just to make sure you all know what it means, because it's a little opaque, basically means you help them help themselves, right? Teach a person to fish or whatever.
Yeah, we almost went with that one, but then he came up with center the contributor, and there was nothing stopping him. So, that, we talked about Rust for Linux. There's something very similar happening now with CPython. So, late last year, there's a pre-pep for adding Rust to CPython. Of course, the name, don't ask me. But in the time since, we've had meetings.
Python.
Yeah, well,
it's going to be good. You heard it here first.
So we've had meetings between the project and the CPython folks, and it's still in the same early days as RFL was, right? We're hearing what problems they're thinking about and what problems they're coming up with. But in RustConf later this year, there will be a talk about it. Come listen. It'll be great.
Yeah, but importantly, this time, we had the playbook, actually, right? And then, actually, I think 3 or 4 of us independently reached out to this Emma Smith person, and we're like, let's talk to you. We would love to welcome you into the project, which is much better than saying, you Python developers are trying to control Rust. I have a trivia question for you, Jack. Do you know what the original name was for a C function, for what we now call an extern C function with a body, like a Rust function callable from C?
Am I supposed to know this?
No, extern crust. That was the actual name, because it was C to Rust. We changed it.
Thank goodness.
Okay.
So of course, right, RFL's one, there's CPython, but who the heck else is using Rust and running into issues?
So, and importantly, what if we're not hearing from them, right? Like, the RFL folks came to us and we heard about it, but what about these other domains where we don't have any contacts?
Yeah, and this is especially important for that beginning bit, where open source communities, they're much more willing and able to come talk to us, but others are not. And so that's one of the things we set out to do with this Vision Doc project. You might, if you were here last year, remember Nico and I giving a presentation about this, where we gave some data about this. In fact, you might have remember us telling you that we got 5,500 responses to the survey. We basically asked things like, what are you using Rust for? How'd you get started? What issues have you run into?
The answer is CLIs, by the way.
It is.
Everyone uses Rust for CLIs. Also other things, but.
Yeah. But in the time since, we've done a series of 70-plus-ish interviews across many different domains, many different experience levels. And we're not going to talk about the data today. It's too much. Nico and I gave a talk at RustConf last year. We talked about some of the data. It's great. What I do want to direct you to is we've been putting out these blog posts from the Vision Doc team where we're basically digging into specific questions or specific ideas and talking about what the data that we have and how it's answering some questions.
Yep. But what we will talk about is one specific area that we talked a lot to, and shout out to Pete right here in the front row, Levasio, who did a lot of the interviews in this area. But one of the things we learned in the Vision Doc was we originally thought we're going to ask some general questions and we're going to come out and have a clear idea, hence the name Vision Doc, of where Rust should go for the next N years or whatever. In fact, what we learned is somewhat more general, but also that we have to do a bunch more of this kind of thing. If we really want to go and understand the problems in a particular area, you really need to get hands-on. And we did that to a certain extent from Safety Critical, and we learned a bunch of things along the way. And also, yeah, big shout out to Ferris Systems, Ferricine. I'm sure some of you are around for having pushed a lot on this in the early days.
And I think Safety Critical is interesting because remember RFL, how they're open source, they're very good at coming to us. Safety Critical is different because a lot of companies in the safety critical space are not open source first, right? They just want to get things done. They don't really care to go fix the upstream bug in the compiler. But we still want to listen to them. We want to have Rust be adopted by them. We just got to find a different way.
I would say we want to do, you even want to lure them in if we can, right?
Maybe.
That's what I think.
So the Rust Foundation opened up this safety critical Rust consortium. Pete is lead, co-lead, I don't know exactly. He does everything, he's awesome. But Lori also, earlier today, I think she's over there, talked a little bit about this. There's over 100 member companies in there now, which is great. And this is good because it provides a place that we can listen to these companies.
What I would say also is, like, if we want to talk to companies in this space, we have to speak their language a little bit, right? You can't just expect them to show up on Zulip and like log in and chat. Like, that's just not how it works. You got to talk company to company first. The actually engineers at the company often will be very happy to show up on Zulip, but you got to have a different kind of connection as you go into different areas besides Linux and Python, right? And that's, I just want to point out one other thing. That building these kind of connections to companies is really important as we look into another problem, which is how can we get more people paid for their work on Rust, right? And so obviously getting more companies involved and happy and satisfied and perhaps even contributing to Rust, first off, will help generate funds for groups like the Rust Foundation Maintainer Fund, the Rust NL Maintainer Team, these kind of really exciting new efforts that are spinning up now for sort of funding undirected work on Rust, and that's good. I would argue it's actually not enough. That's like half the problem. But if you go back to our definition of open source, where it's people helping themselves, I think we also want not just undirected contribution to Rust, but I want people from those companies to come and get involved in Rust and do the work that matters to them, right? Like, I want their opinionated version of, actually, I'm coming with a real safety critical hat. This is important. Because that's how we know, that's how we actually stretch Rust to do more things than just the things that we, the existing folks who've been working on it for years, are already familiar with, right? And so what we really want, we have to engage companies on both these levels, supporting the undirected sort of maintenance and driving things that are important to them and being firsthand involved in the community. And for that, we have to really build stronger connections.
Now, I want to tell you the other side of the story, right? When process breaks down. So, MCDC.
Highway to Hell, right? Or no, I don't know.
No, not the band. Actually, MCDC is this interesting thing. Don't ask me the details. I'm not a safety critical person. But it's essentially like knowing all the different conditions that can happen in your program and ensuring that they're all tested and covered. And it's important for safety critical. A lot of specifications require it. NASA, from what I understand, requires like all their code to be 100% MCDC tested. It's important. And so for using Rust in safety critical applications, we need MCDC support. And sure enough, a few years ago, we had some contributor from the, I assume, the safety critical area wanting to add MCDC support. They opened a PR, it got merged. Great, right? Well.
Yeah, what's the problem?
Yeah, well, unfortunately, open source is harder, right? It's not just implementation, and it's maintenance. And in this case, the maintenance wasn't there, and a year and a half, it got removed. And this can happen often, right? Because it's not just safety critical, right? Any domain, any industry, any individual, any company is going to want to do the things. And it's not just having them shout at us and we hear the loudest thing and implement it, but it's about integrating it into the processes. And so this time around, we have a project goal. We have connections between the people doing the implementation and the maintenance and the teams that are responsible for those.
And I would add, importantly, we've conveyed, right, and we're trying to get across this idea of like, actually, Rust is not a customer service organization. Like, we're not here to deliver the feature. Rather, we're here to work with you to have it meet your needs, right? And I think people are very open to that message, but they have to actually get it because it's not obvious to them that that's how it should work.
And so this is great.
One other thing I want to add on that point is that I think another important thing that's changed is the consortium, right? Because the reality is, you know, individual companies can come and go and they have needs, but I feel a lot better if we're able to work with the consortium and say, hey, safety critical consortium, like, is this a feature that's important to you, and would you collectively like to maintain it? It's a lot more, it's a lot harder for that to just disappear off everyone's radar. All right, now you can go.
Back to Lori. Go watch the recording of her talk if you weren't there. She was talking about all Rust global things. Awesome. One thing she's been really involved with at the Rust Foundation is setting up this Rust commercial network. Now, since you're my friends, it's not launched yet, it's a secret. Okay, it's not a secret, but it's not launched yet. But it's effectively this like, yeah, see, she said it herself, okay? Like, I didn't say it first, thank goodness. I asked her first if it was okay for us to talk about it. She said yes.
This was taken earlier today.
Yeah.
That's cool.
So, and yeah, the QR code does work, and it's a big screen, so it should work fine. But it's supposed to be a network, right? Where it's companies, advocates, Rust project members, individuals, essentially a group of people coming together to try to advance Rust in commercial settings.
All right.
Still being launched, but if you're interested,
so
QR code.
The way I see it is, and here I'm just going to talk about what I want it to become, I suppose, but a little bit. But I see it as generalizing this consortium pattern, right? Just like we took the pattern we used for Linux and we generalized it and applied it in other domains like Python. This consortium pattern has been really successful. So can we generalize it? Can we have groups of people get together, talk about what they need? A lot of times those needs can be met without any involvement from anyone outside the group, like writing libraries or agreeing on a common set of standards. And when they can't, let's have project and ecosystem, for that matter, because a lot of this is bigger than the Rust project, folks involved so that we can bring those needs back and actually get them met, right? And sort of learn from each other. I think it's going to be cool.
All right. You may be saying, I don't want to help. I just want to know what's happening. I'm not going to be able to see anyone, but I'm just going to ask you to raise your hands. Who has like tried to follow a language feature and like just know where it's at? Okay, not as many hands as I might expect, but maybe I'm just blind with the lights. It could be happening. Well, we're not very good at this, right? We need to tell people what we're doing, right? And you might say, if you've been listening to talk, aren't project goals going to help with this? And yeah, they do, right?
Dark mode is rough here, I just want to say, for this. What you can't see is there's a bunch of roadmaps there.
So one thing we're doing this time around is we're trying to group, I think this was also last time, but we're doing better. We're trying to group all the different project goals roughly into an area that they're happening, right? So I think we have add async and things like this.
Yeah, it's not all of them, I would say, but many. We've got a bunch of high-level roadmaps, and I like the plural on that, by the way. I think in the past we did a roadmap. I think Rust has gotten, that wouldn't scale to where we're at now, but roadmaps is working pretty well, of important things like Project Zero, knock out every soundness bug, find LCNR, and he'll talk to you all about it. Stuff like that. Rust for Linux is a project goal, or a roadmap. There you go.
And then there's this other team that's been spun up fairly recently called the content team. Also, Pete is on this, in case you didn't know. This team is essentially trying to work on doing public interviews, so sort of like the Vision Doc was more private interviews for us, but doing public interviews to tell people about what we're all doing, including the project, and I don't know. I was looking at the playlist. There's a QR link to the YouTube channel. Everything on there except the 1.95 release notes, which is new. Everything is from RustConf, but I know they're doing more, so keep an eye on it.
In fact, I think they're doing some at Rust Week. Yeah. So that brings us to the end. I guess what we'd like you to, if I could convey to you one thing, it's not these specific mechanisms like project goals and the user research teams and commercial network. It's the idea that if we want to build a community where the new users of Rust are also coming and joining us as maintainers and helping grow Rust, that won't happen by accident. We have to engineer it, right? And so this is what we've tried so far. I think there's lots of tuning to be done, but I would love and encourage anyone who has ideas to come and talk to us or elsewhere, or just come and join in the conversation on how we can make Rust a more inclusive place with more success in recruiting maintainers from everywhere.
That's it. Thank you all.
All right. Thank you so much. Are there any questions? There's a shy hand over there. In the middle.
Whoa.
My question is just are there other languages or big open source projects that you think are doing this really well? Or is this sort of in the class of problem of this is really hard and no one does a great job of it?
I don't want to say that no other languages are doing this because I don't want to speak in absolutes. And I could say no, and then I find out someone's like, hey, this other language has been doing it. I don't want to look bad. I'll say I don't know. I haven't seen any. One thing that we want to do out of the Vision Doc work is we want to actually publish our methodology, right? Not the results themselves, I mean, we do, but we want to tell other people, not just language designers, but also researchers, how do you do language design by listening to users, right? Survey what people need and the problems they're having. So no, but we want to help that happen.
So I'll add, I'm not sure if I would say they're doing the same things, but I think we could look to and learn from other communities, especially some of the bigger ones like CNCF and, I don't know, OpenStack. I was talking to some folks who were involved with that, telling us some of the way they thought about these problems. They may not be directly applicable in all cases, but it's similar work.
All right, more questions. Where can the catch box go? I see all the way up there.
Oh, man.
Well, pretty good throw, actually.
For those at home, people are tossing a cube. It's impressive. Yeah.
Thank you for the talk. I enjoyed it. One thing I was wondering was one thing you mentioned was sort of that individual language features would be put into buckets where a certain industry would be interested in them. What does this mean for features that maybe don't fit into any category and they're just sort of there? Do they now have a harder time getting into it?
So I'll clarify a few things. First off, being in like one of those roadmap lists is not a prerequisite to being accepted. It's not, in fact, doesn't influence that process at all, technically speaking. What it does do is help direct attention, possibly in the future funding and other things. So it can have a sort of indirect effect where it provides for people to contribute to. So that's one thing. I definitely think there'll be a number of smaller features like, I don't know, let else or something, or if let, that are never going to make it into a roadmap but are still cool and they'll still go forward. On the flip side, there are some things like const generics that are really widely applicable to a lot of domains, but they're almost so widely applicable that it's impossible to make the case for them in any one domain. And in those cases, we've kind of made dedicated roadmaps for them. And I think one of the challenges we have is connecting that to people who have funding and so on, and helping them connect the dots to this would make your life better if this work progressed. Right.
Really, thank you very much.
Maybe one more. Oh, there's all the way in the front here. There goes the box.
Oh my God.
It doesn't have to go in one hop. It can just.
That was. I'm scared.
Oh, nice.
Okay. Yeah. I want to ask, what do you think about this year's iteration of project goals, and what do you plan to change next time? Because for me, as someone who is a bit on the project, but I mostly observe what's happening, it felt like pretty heavyweight. So I want to ask, how do you feel about it in retrospect from this year?
I don't do project goals, but I'm going to put my opinion in. So I think it is heavyweight. I don't think that's a good thing. I don't think it's been more heavyweight this year than last year's, or last, project goals. I think probably in the future. So one thing that is a little bit different this year and this time around than previous is this time around it's project goals for the year, right? Whereas previous ones have been half years. And part of this, I think, is due to scheduling and overhead of collecting the project goals and things like this. I would like to see project goals be somewhat of a mix, right? I'd like to see us thinking about the year, but also them being more dynamic, right? And finding ways to sort of, in the middle of the year, be able to say, actually, we have this, let's put it in. It's difficult, and it's a mix, because I think part of the good, a big strength of the project goals is being able to have sort of everything on the table for teams to be able to say, we want to prioritize this versus everything. So I don't think you can make it fully dynamic. But having a lighter weight process is good.
Yeah, I agree. It was too heavyweight. But we actually, that's a great advertisement for those of you who'll be at the All Hands running a retrospective to talk about exactly these kind of questions. My take, I agree with Jack. I would like to make it more dynamic. I kind of think the roadmaps might be a good thing for us to talk about in a more upfront way, and the project finer-grained goals be more rolling basis. But that's something we can talk about at the All Hands. Yeah.
All right, thank you so much. Please give it up for Nico and Jik. We'll be back with you shortly.
Test. 1, 2. Yeah? Okay, thanks. Yeah. Okay, everybody take their seats. We got a couple of minutes before the next talk. I'll give everybody a couple of more seconds to find a place. See, I'm slowly dimming the lights. And off we go soon. And then the final talk of the day. I can't believe the day went so fast. Everybody enjoy themselves? Yeah? I'm so happy to hear that. Well, last talk, well, she's on basically everything. The Android Rust team at Google works for Rust for Linux and Tokyo, and the advisor on the Rust language team has written multiple Linux kernel drivers in Rust. Right, the list keeps going. I'm very proud to introduce Alice Real.
Thank you. All right. I was going to say I'm so happy to see so many people here, but the light's so bright I can't see any of you. So, but there's a lot of people here, and it's super cool to be here again. Yeah. So today I want to talk about what's happening in I/O. There have been some interesting changes in how people are doing I/O recently, and this has some interesting consequences for async Rust. So it's not quite this bad, okay? But you know, so in async Rust, you might perhaps call it. There's this thing you might call the innovator's dilemma, where you say you're coming up with these things, all these new APIs, these new ways of doing things. And you're inevitably going to make some decisions that come back to haunt you later. And no, I'm not talking about PIN. So in this case, you know, we designed async Rust. We have these async read and async write traits. They were designed really well to work with EPOL, the big primary API for doing I/O on Linux. But then at some point in 2019, Linux came along and said, hey, actually we have this new API called IOuring, and it works completely differently. Okay, but before we can talk about all of this, I have to give some context. So the title of my talk is Completion-Based I/O, but what is it? And I actually can't answer this question yet. First, we have to figure out what is readiness-based I/O. So readiness-based I/O is the old way of doing I/O. And completion-based is the new one. So I thought it would be appropriate that now that we're in a cinema, I would show you a little movie of how the different kinds of I/Os work. So here we have our application, the little crap, and then we have the operating system that could be Linux or Windows or Mac or whatever. And so the old model, the readiness-based one, works like this. So Rust comes along and says, I want to write this little package of data over the network. We go to the OS. The OS says, I can't write this right now. Please come back later. And then the application can go back and wait a bit. Eventually, the OS says, OK, I'm ready now. And then the application comes along with the data. We give it to the OS. The OS says, OK, and we're done. So the interesting thing to note here is that with readiness-based I/O, the old model, all of the waiting happens in the application, right? The OS just says, come back later. I can't wait. The OS goes from 0% done to 100% done basically instantly. That's the old model. in the new model, we instead go like this. We have our application. We're going to write something. And then the OS just says, I'm on it. It will start working in the background. The application can go away and do something else. And the OS will keep working on this in the background. Then at some point, it finishes. And then afterwards, the application can come back and write more stuff. So we moved the waiting into the OS. So the problem is that readiness-based I/O so we have these traits called async read and async write, and they're readiness-based. And so this means that the application level, the code in the application, has the same model. You do the poll, and then you get told, come back later, or you get told it's OK. And so the traits are also readiness-based. And the problem is that you may have heard of leaky abstractions. You can expose completion-based I/O on these traits, but it's not a perfect abstraction. That's the problem. Some people say you can't do it. That's not true. You absolutely can. It's just not quite as perfect as we would like. OK, but why is it that we have to care about all of these completion-based I/Os? I mean, OK, Linux introduced this IOuring thing, but why not just use the old thing? Well, I want to look a bit at the history. And so I've categorized all of the different APIs that different operating systems have used for I/O into readiness-based and completion-based. The blue ones are readiness-based, and the red ones are completion-based. So in the beginning, on Unix, they came up with this thing called select and this thing called poll. And these were the original I/O APIs for doing async I/O. This is all async stuff. That was all well and good. Microsoft came along, and Windows wanted their own model, so they came up with something called I/O completion ports. And so in the beginning, we had Windows with I/O completion ports, which is completion-based, and Unix with the readiness-based model. But Windows also needed something readiness-based, so they have something called AFD, which is the super secret undocumented API, but it's readiness-based. So OK, at some point they found out that this poll API is actually kind of inefficient. You have to keep looping over all of your I/O resources, so it's slow. It's slow, basically. So they came up with this KQ thing on BSD and Mac. And on the Linux side, they came up with epoll. And KQ and epoll are the big APIs we're still using to this day. They're the readiness-based one. And look, they're all the way to the left. There's also this AIO thing, async I/O, which is a Linux API, but it's kind of quirky, and we're not really able to use it for most things in async Rust. And at this time, Solaris and IBM's AX also came up with some readiness-based I/Os, and then nothing happened for a long time. Windows was dabbling with this Rio thing, which was, I think it was useful for high-frequency trading or something. It's not so important. The point is, there was this long period of time where nothing happened. And then, in 2019, Linux comes along with this new API called IOuring. And this basically, and this API really is quite interesting and does a lot of stuff that we haven't been able to do before. So not only is it completion-based, but it also allows you to submit many I/O operations all at once. So you might have 100 different I/O operations in a single syscall. So IOuring has the potential of being really cheap to use. That's pretty cool. Windows immediately copied it. IOrings is the Windows variant of this. And of course, we also can't forget about WebAssembly. WebAssembly is supposed to be platform agnostic. And so they have their own native WebAssembly APIs that are, of course, backed by the underlying OS's API. And so WebAssembly originally did a readiness-based API, but WebAssembly then said, okay, actually it looks like the industry is moving towards completion-based, so let's make the native WebAssembly API into something completion-based. And that's really the thing I want you to get away with. All the new I/O interfaces that we're seeing coming out, they are completion-based. And so the situation is that completion-based I/O, so it's nice for a bunch of reasons. It works better with the new NVMe drives that are not sequential like the old spinning disks. But the thing is, completion-based I/O gives more options to the OS, more ways the OS can do things, which inevitably takes away possibilities from the application. And this is why it's so hard, because now you have an API that could do things, and now it can no longer do those things. I mean, maybe it can still do those things, but in a different way. I mean, usually that's the case, right? So just to give one example, I have another movie for you. So we have our application. This is the disk. So we go get our data from the disk, and then we want to write it over the network. So what happens is that with readiness-based I/O, the machine might say, you can't do this right now. Please try again later. And then Ferris thinks, I have seen the current RAM prices. I'm going to discard this. And then, we wait a bit. We can just read it from disk again. No reason to keep it in memory. So now, of course, you might say that if the modern API consumes more memory than the old one, maybe we shouldn't be switching to it. But they have solutions for that problem too. But it's just to say that this is something you could do pretty straightforwardly with the old APIs. You can't do this with the new one. And so if Tokyo or another async runtime has an application that tries to do this, then Tokyo has to do some sort of translation to make this possible when the underlying primitives don't support it. Okay, I want to show you what are we actually already doing, because there's actually been a lot of super cool work in this space. So the situation for file I/O, file I/O has always been this place where async Rust has not been super happy, but completion-based is basically a complete improvement with no downsides for file I/O. So it's all sunshine and rainbows. So let me try to explain the problem. The Tokyo tutorial on the very, very first page says this. You should not use Tokyo if all you're doing is reading a bunch of files. You might think that, oh, I'll spawn all these async tasks, and then they'll read the files in parallel, and it'll be super fast. No. Because the operating system historically has not provided any APIs to read files asynchronously, we had to use a thread pool with synchronous API, which is really expensive. But now we have the possibility of using this new IOuring API to do file I/O, and now we can actually cross this out, at least once we do that. And actually, we already support this behind a feature flag in Tokyo. So if you have a web server that serves files from the disk, you can just turn on this feature flag right now, and it will start using IOuring to read data from the disk. So, this is the low-hanging fruit files, and we've taken it. Okay. But what about networking? Networking is where the hard part is. And there's been a lot of different projects that have said, okay, we can't really support the old APIs, so we'll just come up with some entirely new API, and then we will expose IOuring through this, and it'll be great. Right, there's the mono IO, glom IO, comp IO, and real runtimes. These are all great. These are all super cool stuff that let you use IOuring, and I think comp IO even also has IO completion ports on Windows, so it's all really cool stuff. But here's the thing. If we actually want people to be able to really use this stuff, we need some amount of backwards compatibility. Like, maybe it's difficult to have full backwards compatibility for all of our I/O, but we are not going to have any meaningful adoption if we don't have good backwards compatibility here with the old stuff. And another challenge is this thing that actually, like I've been talking about this as we have readiness-based I/O and we have completion-based I/O, and that's it. There are two things. But actually, completion-based I/O has several factors. It's not just a single thing. So one interesting example is this idea of buffer pools, which some completion-based I/Os, IOuring supports this, but some of the others don't. And buffer pools are this idea. I think I have a movie. No, I don't. But OK, so buffer pools is this idea that you come along and you have a million different connections open, right? And when any of those connections receive data, you need to go read that data. And if you just have a naive completion-based I/O, then you have to have a separate buffer for every single connection. Right, so you have, I don't know how big a buffer is, a kilobyte times a million connections. It's going to be a lot of memory, right? This is your cost, right? So buffer pools is the solution that IOuring came up with. The idea is that we have, the application says here's 1,000 buffers, and here's 1 million ongoing reads on my network file descriptors. Once a read actually happens, go take one of the buffers, right? And if you run out, I'll give you some back eventually, and then we can continue. So in this case, we've solved the RAM problem, so to say. Another interesting example is this idea of chained operations, which this is some. I have a video for this. Okay. So the application says, read this from the file and then send it over the network in one message, right? And the OS says, I'm on it. The application goes away. Now we read from disk. Okay, so the OS has now read from disk. And then the operating system, without any input from the application, will continue on to the next operation in the chain. And then we will write it to the network. And of course, then the application can come back and tell the OS to do something else. Yeah. So all of this, what my point is to say is that completion-based I/O actually has a lot of different things. And we need to be careful that we don't have this problem again, right? Because you could imagine that we design some new APIs, and it supports the naive completion-based stuff, but it doesn't support buffer pools or chained operations. I know that several of those 6 projects, like some of those projects that I showed on the page earlier with 6 projects, only some of them support buffer pools, right? And so we need to be careful that, like, let's say we got the entire Rust community to spend the huge cost on the adoption of the new API, and then we say, OK, let's do it again. Let's not do that. I have some options. So what can we do about it? So this is the file solution. So the old I/O traits, the readiness-based one, you can totally use them with completion-based I/O. And this is how files work. You just have to copy the data one extra time. That's the cost. So the application comes with the data, Tokyo makes a copy. And, and then Tokyo says to the application, okay, I'm done writing. I'm done now. And then afterwards, Tokyo goes to the OS and starts writing with completion-based I/O. So this is kind of interesting. This means that the application actually has to flush if it wants to be sure that the writing has finished. Right? This is one of the things you get when you have to patch completion-based I/O over readiness-based I/O. I mean, of course, you should flush anyway. Please flush your I/O resources. But if you take something like TCP stream, the way it works today is that you don't need to flush because the ePOL API doesn't have anything equivalent to flush. You go from 0% done to 100% done in one step. So there's no need to flush. Another thing that I think is kind of interesting is that not all I/O in the ecosystem is using async read. So let me show you what you mean. Okay, so here's the idea. We have our application. It goes into some framework. Maybe you have Axum as your web server, or you have gRPC or Atonic or whatever you got. And of course, behind the scenes, this uses TCP stream from Tokyo. And what we really want to do is to say, okay, we have readiness or completion-based. It all works transparently, like it did for files. But this is really hard. What if we could split here instead? So let's say we have TCP stream 2, and then Axum starts using that. And now all of the applications using Axum suddenly start using IOuring for their stuff without the applications having to change anything. Of course, this still comes at some cost. Axum and Actix and Tonic and all of those have to switch, but at least all of the applications don't have to do anything. So this is also an approach we can take. The interesting thing here is that a lot of these frameworks, they use something called stream of bytes. So this is kind of like an async iterator. You await for the next chunk, and then you get a chunk of bytes to be read or something you want to write. This is used a lot in the web ecosystem instead of async read and async write. And they did this for completely other reasons. They did this because stream of bytes is executor agnostic. But it turns out that stream of bytes also supports completion-based I/O just as easily as readiness-based I/O. So because a lot of the ecosystem is doing this, we can easily swap all of them to readiness-based I/O just by swapping out the stream. A lot of them use something called a body, but it's the same thing. Like, it's the body of your HTTP request. It's a stream of bytes, usually. So that's pretty cool. Option 3, we can just keep using readiness-based I/O. Windows has AFD, and they take backwards compatibility pretty seriously. Linux has ePOL, and they take backwards compatibility pretty seriously. Just keep using ePOL, or keep using readiness-based I/O. And I actually think this is a real thing. I think at least the async read on TCP stream in Tokyo will have to keep using readiness-based I/O forever. But here's the kind of interesting thing. That doesn't mean we can't switch to IOuring, because IOuring, everybody knows it's completion-based, but actually it can do readiness-based too. So there's this thing, it's the IOuring thing for doing readiness-based I/O. We could use this in Tokyo if anybody wants to. Or, we could just say, we are just going to use ePOL and IOuring at the same time. This is what Tokyo does today if you're using it for file I/O. It also works fine. Interestingly, Wasm, which has these native completion-based I/Os, also support readiness-based. If you do a 0-length read or write, then it's actually readiness-based I/O. So a lot of these platforms actually like I guess they acknowledge that they can't just not support readiness-based I/O at all. That's not going to work. So I guess ultimately, what it comes down to is that I think we have to do both. Make it possible for people to start using completion-based I/O, IOuring, and probably also I/O completion ports on Windows. Make this possible, and then we'll have some sort of situation where file is going to, use the new stuff with an extra copy. Axiom or whatever framework you have can switch to using the new completion-based API. TCP stream can stay on the old stuff with readiness-based I/O. And I think this is the way to go. So, gradual adoption. Don't try to go all in, right? I mean, it's super cool that for file, we can say, now you're going to switch to IOuring and just use that, right? But even for files, not all platforms support IOuring. I mean, some disable it, but I mean, that's Windows, right? Or Mac. So, yeah, I think this really is the situation. We have to move towards a ecosystem where you can do both. And once we can do both, we can go to 5% and to 10% and to 15% and to 90%.
Thank you, Alice. Thank you so much. Are there some questions for Alex?
Hey, I was just curious. So a couple of things you mentioned. One of them was that stream of bytes could natively support completion-based APIs. I'm curious how that works without requiring an extra copy. Maybe I'm not familiar. I'm remembering the IOuring APIs enough, but I thought that they were OS-provided buffers, but maybe they're not, and that's wrong.
No, you can give it any pointer.
Oh, okay, that makes sense then.
You just have to keep the pointer alive for the duration of the OS using it.
Got it. And then one other thing that I don't think you mentioned, but maybe you did, was the async buff write traits. Do you want to talk a little bit about how that interacts with the system and whether that's something you considered using more broadly or like having be a tool inside the ecosystem?
So async buff read could also support completion-based I/O, but I mean the thing is, so async buff read has async read as a super trait. So it's kind of tricky to do it, but it's true that when you're using the buff read version, you could have some internal buffer and you could read into it and you could provide the buffer directly. So yes, that API can also support it. But it doesn't change the fact that you have to support both if you go that route.
Got it. I actually didn't realize that that was a super trait in Tokyo. I could imagine a version of the trait that didn't have that requirement, but cool. Thanks for explaining.
It would be super cool if buff reader of TCP stream could use completion-based I/O behind the scenes, even if TCP stream on its own can't. But I think that's getting into some interesting language questions about specialization and stuff. So.
Oh no. All right. Any more questions?
Hi. Thanks for the talk. I was wondering, so you mentioned basically Tokyo would need adjustments to use completion-based I/O everywhere, and maybe in a different version of this history where the timeline was a bit different. It would all be completion-based from the start or something. But if you could go back and change actually the futures trait itself, is there anything you would change about that, or is that the way the trait works and looks with its poll method? Is that still the right design also in a world of completion-based I/O?
Yeah, I think there's nothing wrong with the future trait. You need to change the I/O traits to better support completion-based, but I don't think you need to change the future trait.
Okay, cool, thanks. Good that the STD doesn't yet have stable async I/O traits then yet, I guess.
Yes, so it's only us who made the mistake. You all are fine.
Thanks for teeing that one up perfectly for me, because that was my next question. So you made some recommendations for what the ecosystem should do. What would you suggest that the standard library do, given that we do eventually want to have async traits? And thankfully, we strategically delayed via extensive bike shedding, and now we're in a position where we don't have any async traits. What would you suggest?
Please stabilize stream.
So first of all, yes. Yes, please. Thank you.
Call it what you want. I don't care.
Sure. But, I mean, things like async read, async write, should we add completion-based APIs here?
Yeah, probably. The thing is, it's actually really hard to figure out how they should look. I don't really have a complete answer, right? The thing with the buffer pool that I mentioned, like as far as I remember, only comp.io has buffer pools, and even there, it's kind of hard-coded which kind of buffer pool it works with. You can't swap out the buffer pool without also swapping out the IO resource. And so I don't think anybody actually has a completion-based IO trait that I feel confident is forwards compatible with all of the fancy stuff, except for stream of bytes. You know, when we originally did Tokyo 1.0 back in like 2020, we were considering, should we delay Tokyo 1.0 by a few months so we could, so to wait for the standard library to stabilize stream? We didn't delay it.
Good call.
All right, maybe one or two more. There's one over here. Oh, box is going somewhere else. I guess that works.
Hi, thanks for the nice talk. On the topic of possibly adding completion-based I/O async to the standard library, would it be sensible to have a completion-based I/O in the standard library and emulate it using readiness I/O? So that only interface is completion-based, but you have basically completion-based in user space?
So I do think that you're always going to have some way of using the readiness-based APIs, because not all platforms can use the completion-based one, even if they have them, for various reasons. And so, luckily, the situation is that if you have a trait that's completion-based, it's pretty easy to back it by readiness-based OS primitives. It's just the reverse is hard.
So completion-based standard I/O in the standard library?
So traits, great. I don't know if we should have actual async TCP stream types, because I think they're too tied in with the runtime. So if you do that, you have to put a runtime in the standard library.
Yeah.
Which we should.
That's a different discussion, right? But just know that if you're going to do that, it means that you have to put a runtime in the standard library.
Okay. Your question?
Hi. I was just wondering, based on you saying that you haven't found any async reads kind of anywhere that you feel would be sufficiently forward compatible, do you feel that's like just us not having come up with something yet, or is it a more fundamental limitation and something like stream is the right level of abstraction to kind of stay at in terms of the standard library?
I think it's possible. So I think for the buffer pool stuff, you can probably do something with some sort of dynamic dispatch, kind of like we did with the Waker to support user-provided buffer pools, for example. I think it can be done, but I think we should start with stream.
All right, one more, anywhere? That way. Oh, almost perfect.
Thank you for the talk. You mentioned that we can use arbitrary pointers for completion-based I/O, but that you would have to keep that data alive. How Tokyo solves that, like at this point? How you protect from drop in the future and all of the stuff going from that?
So you're getting into the whole thing of, so I just said, okay, completion-based I/O is hard. Now you're getting into why. So yes, it's hard because with the current APIs, you can't keep the buffers alive. So the solution is that, so Tokyo's file type has its own internal buffer for the data that the file owns. And if you drop the file while there's an ongoing operation, the buffer is not freed at that point. It's freed once the kernel comes back with the result of your read or write that you had pending. So the runtime is going to keep track of this buffer internally, even though you drop the file, if there's an ongoing operation, so that it can free it once it's possible to free.
Thank you. Makes sense.
Yeah.
All right, all right. I'll quickly say a few things. We have drinks until 7. The cinema rooms need to be cleared out by 6. And we'd like to all see you back tomorrow. We open at 8:30 again. And please give one more round of applause to Alice. See you all tomorrow.